All right, morning, everyone. My name is Lucas Dedrick. I'm Section Chief for DSPS and AWC and Field Services. This is Ed Lisinski with the American Wood Council. He's going to be putting on a presentation today for mass timber and shear wall. Thank you all for attending this. I guess before we get started, does anybody have any questions?
Did the department move the commercial building code package for adopted in 2021 over to the legislature yet?
That's a good question for you to answer. And I know you're gonna answer it.
I was hoping you might have some insight.
No, I don't have anything on it.
Okay.
A certain due date that if it wasn't done before prior to, was that June 1st?
It was in June because when you open up an administrative code, you get 2.5 years. That 2.5 years, you have to have something for the legislature before that date. Failing that, you close it, you have to start over.
Yeah, unfortunately, I don't have anything on that. This is a sign-on sheet. If you could, I'll pass it around. Put your name and credential numbers on there. Then get your CEUs to you next week, please. Other than that, if nobody has any questions, I'll let you get going.
All right, thanks for having me. And just to check, making sure everybody can hear me online, if somebody could maybe drop something into the chat quick to make sure that you can hear me. Give it a thumbs up.
They can hear us.
All right, awesome. So hi, everybody, thanks for coming out. Like Lucas said, my name's Ed Lisinski. I'm with the American Wood Council. I know a lot of you in the room here because I used to work in the city of West Dallas. You know, as a planning examiner and then building official, director of the department there for, I worked for West Dallas for 16 years. Actually now about 2 years ago or so, Jim Smith, who I know everybody knows, called me up and said, "Hey, I'm retired from the Wood Council. This would be a great job for you. Are you interested?" And I said, "Heck yeah." So about 1.5 years ago or so, I jumped over to the Wood Council and been loving it ever since. So I'm their Midwest Regional Manager, which means I get 13 states up here in the Midwest that I get to travel around to. My job consists of pretty much 3 things. I do a lot of code development, both nationally and state and local. So I've been sitting in on the mass timber code stuff that you you guys are working on right now. The mass timber task force and the AWC adoption and all that stuff. So I get to do a lot of that stuff, get to work on a lot of national codes, things like that as well. Second part of my job is to come out, do trainings for building officials. We're free for building officials and building inspectors, fire officials, anything like that. So, if you like any of this stuff or you have other topics that you're interested in, we have one of my cards. I got to stack them up there. I'll come out to any chapter meetings or large jurisdictions or state meetings, anything like that, and put on any training like this. I'm free, but you get what you pay for. And then third part of my job is answering questions for you guys. So I'm your wood resource. So any questions that you guys have, feel free to give me a call anytime, shoot me an email. If I don't know it, which I probably won't, I have a whole team back at the office of engineers and environmental specialists and stuff like that. So any realm of wood construction questions that you guys might have, I've probably got a team back home that I can work with. So I get to work on my house. I'm still based out of West Dallas, out of the Milwaukee area there. And then I guess a little bit more about me. I'm still certified here in Wisconsin. I'm a professional engineer and some stuff like that. So anyway, what we got today, we got about 3 hours of mass timber and then about 1.5 hours or so of shear walls, 2 hours, I think is what the class is for. So we'll do that. I like to take breaks every hour if that's all right with you guys, just because, I've sat in the same seats that you guys have been sitting in for years. So I know how boring that can be. So every hour I'll get you up, moving around for 5-10 minutes or so. We'll take a lunch break from 12 to 1. After the lunch, I'll probably have to wrap up a little bit more of the mass timber stuff after lunch a little bit. We'll see how far we get. And then we'll get into some of that shear wall stuff later on, and then some Q&A at the end. We do have programs that are based off of frequently asked questions. So even if you guys run into something that you've never run into before, even if you get it resolved and everything, still, send me an email or something, let's talk about it a little bit, just because if you guys run into it and you guys have a question on it.
Hey, Ed, can we hold up 1 second?
Sure.
Secretary Harris, here, you'd just like to say hi.
Yeah, definitely.
Thank you. Hey, how's it going? Good to see you.
Hey, Ed,
Hey,
it's been a few years.
yeah, how you been?
I'm good.
Good,
Good to
good.
see you. You've gone to the dark side.
I have.
So, well, really appreciate everybody coming here. Mass timber is obviously something that in your communities you're probably hearing about, builders are interested in it. Actually, believe it or not, random connection, one of my cousins is an architect out in Boston, who specializes in the stuff. Wisconsin has a long history of building products and particularly in wood building products. And so I think we see this from the department's perspective as potential win-win for the state of Wisconsin in terms of trying to jump on board with new building products that could also spur new industry, particularly in the northern half of the state. One interesting fact over from DNR, Wisconsin only utilizes 60% of its sustainably harvestable timber, meaning we could double our use of and our harvest of our timber without hurting our forests and our kind of our natural areas throughout the state. I see a guy with a fire shirt in the background. One thing to note, many of you probably already know this, our department also regulates the fire industry. So a big part of this conversation is not just, does it look pretty? Can we make a building with it? But it's like, can we also keep people safe while we're doing that? Can we make sure that we're doing the right thing by economic development, that we're doing the right thing by our architects? I know there's probably some in the room, but they're often focused on making stuff look pretty. And can we also do the right thing, keeping people safe? And in particular, as we grow the height of these buildings, I think one of the key things for me is the fact that most of our ladder trucks in this state don't reach some of these heights. So when we start talking about time to exit and some of those key details for building safety, it's really critical that we either make sure the science supports it, or that we make sure that we can mitigate, the potential hazards of different materials, and that comes along with every material that we encounter. So we're going to be releasing a mass timber building guide here in the next few months. I think I've been saying the next few months for at least a year. These things always take longer than you want, so we're real excited about that. But at the end of the day, the other part of this, and the credit goes to the crew, our folks like Randy, our folks like Brandon, and Lucas in the room. We want to put on trainings to sort of better engage with our local inspectors, because at the end of the day, you all are our eyes and our ears throughout communities in the state, and that relationship is extremely important to us. So I know I just said a whole lot of nice words. Really appreciate the opportunity to do so. My door's always open if you need it, but I hope you get something out of the training. And thanks for a few minutes. Ed.
Oh, absolutely, absolutely. Yeah, and thanks for that. With that, yeah, we'll jump right into this then. Any questions before we get started? All right. And now my clicker's not gonna work. No, nothing's gonna work. It was working a second ago. Yeah. Yeah, there we go. All right. The class description, basically, we're just gonna go through everything about mass timber that's in the 2021 code. So we're gonna start off just with what is mass timber. A little bit of, how was the code developed? We'll get into what's in the 2015 to 2018 code as well, as we start to build up to what's in the 2021 code. Talk about how ICC developed all that, and then we'll get into what's in the 2021 code. What can you build with this new stuff? Now, obviously, I know Wisconsin's still on the 15, moving towards 21. Hopefully, we have the 21 pretty soon. But even if we're not on the 21 yet, we are starting to see a lot of projects. There's one here in Madison, one in the Ascent Tower in Milwaukee, where people are starting to use the 21 and even the 2024 IBC to come in with alternative means materials, get a variance using those codes. So it's good to know kind of the background, what's in there, why is it in there, that type of stuff. even if we're not on that code yet. I hear a lot from a lot of people, we're not Milwaukee, we're not Madison, we're not gonna get, 18-story skyscrapers made out of wood. And I agree with that. We'll actually see some pictures, with some of this mass timber. There's hotel developers, there's, apartment developers, things like that are looking at using mass timber as well. Even for, 3-story, 4-story buildings. There's even some, some little utility structures and things like that that are starting to use mass timber as well. So yes, you might not get the big, huge ones, but you're probably going to get mass timber at some point. There's just so many benefits with it that you probably will see quite a bit of that pop up, in all communities. Learning objectives, kind of the same thing as the summary. I won't go through that. The outline, don't worry about the breaks that are on there. We're going to do breaks as we go, but all right, real quick though, what's everybody's job function here? So how many plan reviewers do I got? A handful of them, inspectors. Most of them, building officials and directors of departments, things like that, yeah. Fire officials, just one in the back there, all right. Any architects, engineers, contract, okay, a couple of those as well, awesome. How many are state employees that are in the room at least? All right, so about half, so, all right, good. All right, so mass timber. So why do we need mass timber? Get asked that a lot, just sort of what's the big deal with this stuff? So here's a time-lapse video. This is a project up in Canada, in British Columbia, Rock Commons. I don't know if you caught the dates on there. It's an 18-story project. Again, I know it's kind of hard to read, but in the lower right-hand corner there were nine carpenters on this whole project. That's all that they had. Putting this whole thing together. We're doing about a 4.5 a week, 18-story building that they get done in 13 weeks. Using mass timber here. So they're using basically glue lamps for beams and columns. They're using CLT for the floors. That's the cross laminated timber. We'll get into that quite a bit in this project. But you can see, glue lamp columns, about 5 to 10 minutes. They're installing that column and they're moving on to the next one. Is there anybody here from Milwaukee that was involved with the assembly building at all? All right, just John. This is real similar to how the Ascent Tower was put together in Milwaukee as well. You see week 7, the facade's going up as they go, so they can kind of keep up with that. They can keep this building enclosed. That whole building was enclosed in about 15 weeks, I think. You can see that they do have non-combustible stair towers. They have concrete stair towers in there. You didn't go later on, anytime get up over 12 stories, they have non-combustible stair towers. So there you go, 13.5 weeks, an 18-story building, all the way up and fully enclosed. There's some of the environmental stuff. I know you guys can't read that, but hear that all the time of, you're cutting down all these trees to make these buildings. What's going to happen to the forests? In those last little hard to read stats that were on there, 6 minutes it took to regrow all that wood for that entire building in North America. So pretty much in the time that, I started talking, well, actually not even, about the time that Secretary Harris stopped and then I started back up, in that time, we grew all that wood to make that 18-story building. So, you're not going to be losing wood. We're always going to have that. We're always going to keep these sustainable forests going. So when we do start talking about codes, always make sure that you're using the right reference standards, right? So 2021 IBC, you're using the 2018 NDS. You're still using the 2015. We actually have the 2015 NDS. Hopefully everybody's at least somewhat familiar with the NDS, or the NDS and then the NDS supplement. So the NDS basically gives you all the formulas, all the equations on how to design wood buildings. The supplement then gives you all the characteristics of the wood, the wood strength properties, the section properties of the members and things like that. So that's how those two documents kind of work together. They are different, but they do work together quite a bit. All right, so when we talk about mass timber, what are we actually talking about, right? So this slide walks you through all the different things that are considered mass timber. If it's not on this list, it's not a mass timber element, okay? And we'll go through each of those in a little bit. But, you know, at least personally, when I started talking about, or started hearing about tall wood buildings and all that type of stuff, I was thinking about traditional stick frame buildings and, you know, how are you taking these and doing 18 stories with this stuff? Just so you know, mass timber has nothing to do with light frame, your conventional light frame construction, right? This is completely different. Yes, they're both made out of wood, but that's where the similarities stop with this stuff. All right, you can't use repetitive members. You can't use wood studs, wood floor joists, wood trusses, anything like that in a mass timber building. You're not going to see any of that stuff. That's why you're able to go so much bigger and taller with this stuff. You know, you think about the mass timber, what do you think about making a campfire, right? Yeah, you got a flame down there, but if you just throw a bunch of really big logs on there, the logs are gonna burn while that flame's there, but as soon as that flame goes out, that match dies out, the fire that's on those big logs is gonna go out pretty quick. It's gonna char, it's gonna protect the inner workings of that log, and it's, you know, you're still gonna have a big log in the morning. But you put a whole bunch of, you know, sticks underneath there, you know, like wood studs or trusses or things like that. You start putting some of these smaller members underneath there. Now you're gonna have a much bigger fire, and that fire is gonna be on that log a lot longer, and yeah, it can burn out that log. So that's why when you have mass timber buildings like this, you're not gonna see any of this traditional stick frame construction in there at all. The interior walls are gonna be, you know, concrete masonry, steel studs and drywall, that type of stuff, but we'll get into that as we go. Where's mass timber allowed? You know, type 1, type 2 construction, obviously it's non-combustible, but in type 1B and in type 2, you can use mass timber elements in roofs in certain circumstances. So heavy timber is allowed in some roof applications in 1B and type 2. You can, in type 3, you've got your non-combustible exterior, but anything interior, you can use mass timber on that. And then types 4, types 5 construction, you can use mass timber throughout anywhere there. And again, mass timber elements are the only combustible elements that you can use structurally in tall mass timber buildings. You still can use, you know, other combustible materials for non-structural purposes. So yeah, you can still have, you know, wood finished floors, wood doors, wood windows, things like that. Chair rail, you know, things like that where you could also use it in type 1, type 2 construction. But structural elements are always going to have mass timber elements. This is on the 2015, you'll know this is table 602.4. In the 2018-2021 code, it actually moved into chapter 23. So 230411 is where you're going to find this later on. But this is a table that gives you your minimum sizes for mass timber elements or for heavy timber elements. Part of the table got cut off, so the numbers don't make a lot of sense, but just so you know that's where it is. You know, if you have a piece of wood and you want to know, hey, can I use this in a mass timber building? It needs to meet these minimum sizes. And again, like I said, the table, one of the columns here got cut off. So this top row is actually columns. The next row down is beams. And then this row is columns. And then this is beams supporting floors and beams supporting a roof, I think. Or something like that. But either way, you know, look at the table. That's going to give you those minimum sizes. All right, so when we talk about mass timber buildings, obviously sawn lumber, that's what you traditionally have seen in mass timber buildings, your old type 4 construction, right? You've got larger pieces of wood, 6x6s or larger. Yeah, on the screen, my little pointer doesn't work either. So anyway, you know, you got beams, posts, all that type of stuff. You guys have seen this 100 times, right? The old traditional type 4 construction. You're going to use the PS20. That's the standard from American Softwood Lumber Board. That's same grading and same rules for that as you would any other piece of wood that's out there. And that's covered in the NDS under Chapter 4. In the NDS supplement, also in Chapter 4, that's where you get your reference values out of it. I'll skip through some of that just because, again, you guys have seen this stuff before. So glue lamps, again, products you guys have seen many, many times, but if I jump back a little bit here. Remember here, you still have to meet these minimum sizes, right? So you've got solid sawn, you've got glue lams, and you've got structural composite over here. So if it's a glue lam, if they're gonna put a glue lam in a mass timber building, it needs to meet these minimum sizes that are in that table. If you're supporting a roof and you've got a column and it's only 5 by 5, you can't use that as a glue lam then, in a mass timber building. It's gotta be meeting those size requirements. All right, so how are glue lamps put together? Basically, you have a whole bunch of 2x or 2x type structures glued together, pressed together, and they make a nice big beam out of it. Again, the wood laminations are bonded together. They're all running in the same direction. Glue lams, the adhesives that they use in there, they're all fire rated and they're exterior rated. So, you can use these exposed in fire. The adhesives are good for that. We'll talk later on about how you have to kind of oversize them to work with that char, but we'll get into that later on. And again, you guys have seen these quite a bit in the past. You got big tall beams, you've got columns on the left there. Again, that Brock Commons video that we watched early on, the Ascent Tower in Milwaukee, that's how this stuff was all put together. If you've ever gone into a church, you've seen the big church arches, big wood arches in the church. That's what they're making those out of glue lamps, right? You can also take glue lamp, lay it on its side, use it as a floor panel, and that's considered a GLT or called a GLT. There's some documents up there of the code acceptance again. So you got the PS20 pops up again just because you're using typically sawn lumber in there. But then also the D3737, that's basically your standard for using glue lamps. That's going to regulate the adhesive that's in there and things like that. There's grade marks on them. It's going to give you a whole bunch of information. If you're out there in the field, make sure that you're checking, the glue lamps that they're sending out match the plans for what the structural engineer designed for. Chapter 5 of the NDS covers glue lamps. They're also in the NDS supplement. They're going to be finger jointed typically, just because you're getting some really long lengths, right? So they're going to have to finger joint a lot of that lumber. So if you do see finger joining in glue lamps, that's perfectly normal. Actually, typically, a lot of times you can, when you do finger joint lumber, you can actually make it a little bit stronger because you can take out some of the knots and bigger imperfections and kind of cut, some of those pieces out, glue it back together, and you're good to go. So when they're making those bigger columns and beams, this is kind of what that looks like in the shop. So they stack this stuff all up together. They have a face bonding layer, clamp it down, pressurize it, sand it down, plane it down, get it out to the job site. There's a church out in Louisville. Bullitt Center in Seattle. This was one of the buildings that was, I think, one of the first ones that was actually certified to be net zero energy for that entire building. So it basically is free. They're not costing anything to have this building up. It's taking in solar, it's collecting rainwater, it's all that type of stuff. So Raleigh-Durham Airport, this was the largest volume of mass timber of glue lam and any project in the country when this was put together. So again, with the glue lams, you can do nice big curves, you can do arches, you can do all sorts of cool designs with that stuff. Cathedral Church of the Light in Oakland. Again, just, again, you guys have seen this stuff before, but you can do really cool things with it, basically. And then even here, a firehouse in Oregon. It's a little bit hard to see, but you can maybe see through the window here, these glue lam arches that are coming up through there. So again, even if you don't have these really big, tall buildings, they're using mass timber. They're using these same concepts in smaller buildings as well. All right. And then, yeah, Denver, the 515, that's the building they're just finishing up now. So. All right, other types of products, nail laminated timber, using that for floor slabs. You can do it in the factory, you can do it out in the field. It's basically just laying down a whole bunch of 2x next to each other, 2x8s or so, and just nailing them off one to the next, right? It's actually been around since 1967. There are code requirements for that nailing, the nail patterns, all that type of stuff. That came in 2018. We'll talk about that in a little bit, about where that actually sits in the code, but again, because it's just regular 2x8s that you're putting together, you just use regular sawn lumber out of the NDS. And then again, out of the NDS supplement as well. And here's where you can start to see some of those getting put together. One thing in this picture here on the left, because all you're doing is just taking one board, laying another board next to it, nailing it off, laying another board next to it, nailing it off. There's not, those nails are gonna move, nails are flexible. So if you need to use that for a diaphragm, you get no diaphragm action out of that, really, right? Those boards are gonna move a little bit to each other. So it might be a little bit hard to see, but this picture on the left here, you can see that they're putting a sheet of 3/4 plywood on top of that. That's to get that diaphragm action out of those floor slabs. So if you do a nail laminated timber, just remember that if you do need that to be have some lateral resistance to it, they typically will need to add something to it like that. But you can kind of see, using it for floors, using it for roofs. Looks very nice. Again, they can do some curves, they can do some different things with it. This is with 2x12s. And going through, yep, here's a project in Minneapolis. There's a nail laminated timber handbook. Not referenced in the code, but it is a guide that's produced out there by Think Wood that kind of walks you through how to put this stuff together. Kind of the cousin of nail laminated timber is dowel laminated timber. Very similar. You're putting, again, a whole bunch of 2x next to each other, but this time you're actually pouring a hole through it, pounding it and gluing in a dowel. So because of that, now you're connecting a little bit more of these, you're gluing all those together, you're making a little bit more of a bond. So these actually can have some lateral resistance properties to them. You don't have to go through it, adding that plywood on top if you need these to be a diaphragm. They'll also do a lot of things with this. You can see on that picture, they can do like acoustic inserts into this as well, a little bit easier. So a lot of times if you see that on a ceiling or on walls, they'll have these acoustic inserts inside of it as well. Here's a project in Des Moines. The one thing about dowel laminated timber though, it's not recognized yet in the AWC. So if somebody does want to use this stuff, the guy go out, get an evaluation service report or have it evaluated another way to make sure that that's going to meet the code. And yes, this is an outdated one. Make sure if you do get, ES reports out there that you're checking the dates on them, make sure that it's up to date. They should not be turning in something like this that says that it's subject to renewal in November of 2020. Make sure that they have one that's not expired yet. So I keep telling myself I got to update that slide. But all right, so that's the mechanically laminated floor systems. Structural composite lumber. Typically, I think everybody in here has probably seen LVLs before, especially over garage doors on residential. But parallel strand lumber as well. Laminated veneer lumber, parallel strand lumber, laminated strand lumber, and oriented strand lumber are the different types of structural composite lumber. There you're taking veneers, gluing those together, all the veneers going in the same direction again. And very similar to putting together glue lamp, but instead of 2x, you're using veneers on that instead. Structural composite lumber is in chapter 8 of the NDS. Each of the manufacturers will usually produce their own strength properties on that though. Otherwise, APA, the American Plywood Association, they produce generic strength properties as well for that stuff. So either check APA publications or the manufacturer specifications for that stuff. But the one thing to remember with that, again, That table 602.4 in the 2015 or 230411 in the 2018 or 2021, you have to meet those minimum size requirements, right? So you're not going to see those small little LVLs that you'll get over a garage door. I think it's 3.5 inches minimum on beams for a width. So again, make sure that you're checking that to make sure that the sizes are appropriate. All right, and then the big one here, cross-laminated timber. This is kind of what allowed us to go bigger and taller with our wood. It's the substitute for concrete and steel on floors, right? So if you haven't seen this stuff yet, basically you're taking a whole bunch of 2x, going one way with them, crossing them with a bunch of 2x, going the other way, crossing them with a bunch of 2x the other way to basically make almost like a sheet of plywood out of 2x. Right? Typically 5-ply or 7-ply, but you can really do these, whatever size that you want them to be. And you end up with a big panel like that. The PRG 320 is the standard for those. There was a big change in 2018. So we'll talk about some of the testing and everything that was done using these in a little bit, but the adhesives that they used in the older stuff, that's what was tested. That's what was used when they wrote the 2021 code. Okay. The PRG 320-18, the new version that came out in 2018, greatly increased the capacity of the adhesives that are used. So now they're doing a whole bunch more testing. And that's why in the 2024 code and beyond, you can almost see these buildings going bigger and being exposed to fire a little bit more. So again, the adhesives that are used are real similar to glue lambs. They're going to be fire resistant and exterior grade. So that again, after all the testing was done to get into the 2021 code, they really improved those adhesives again, and that's why in the future you're going to start to see even more expanded use of this stuff in the codes. Cross-laminated timber does have its own section in the NPS. And here's a brief little history of CLT. So, started getting used in France in the mid 80s. It started taking over throughout Europe in the early 2000s. They started really looking at that. Started improving the presses and improving some of the manufacturing processes that were done with this stuff. And there's over 500 CLT buildings in England. And then more recently started to use it over here in the US and Canada. I get asked all the time, just what's sort of holding them back right now from really using this stuff. We'll look at some of the advantages and stuff of this later on, but what's sort of holding it back? And really, it's just that there's not a lot of places over here that are manufacturing this yet. I think that right now, fully operational, I think there's only like 5 plants that are in the US and Canada that are manufacturing this stuff. There's plans for another at least 3 or 4 that are going to be coming online probably this year or next year. But it's still that's really what was holding this stuff up. I
would also add that the reason some of this is being held up is the lack of familiarity, not only to the design professionals, but also to the inspection and fire groups.
Yep.
Recently, a point of contention from a local fire department concerning a heavy timber proposed building was the fact that even though there's testing being performed, for charring for these heavy timber columns and floors, etc., the challenge comes in that it's still a test.
Yep.
And it's not a real life building. And because one, there are very few heavy timber buildings at this point in time.
Yeah.
And 2, those buildings that have been built, fortunately, or whatever word you want to use, have not had fire events. So there's no reference point as to what works or doesn't work. So there's a lot of susceptibility and a lot of questioning of those designs. And the code is a living document. I mean, that's just the reality. Every 3 years, there's new technology, new information. Back in 1996, the MGM had a fire on the first floor. That fire never killed anyone. But the smoke from the first floor went to the top floor and it killed everyone on the top floor. And that's the reason we have smoke dampers and elevator protection now. 9/11, high-rise building hit with an airplane. Well, you're not going to design a building to withstand an airplane. But the reality is they only had one stair shaft for scissor stairs, and you can't build them anymore. The code learned from that experience. The problem right now that I see, and as I've been told to me by other professionals and peers, is they aren't comfortable with heavy timber right now because there's no experience as to how they will work in the field. Now, don't get me wrong, there's testing to be formed to, on the viability and charring and all that.
Yeah.
So just, that's what I'm here.
Oh, yeah, absolutely, and I'm glad you didn't call out Bill Sullivan by name, because he's not here to defend himself, so that's good, but, but no, yeah, and I completely agree with you, and that's why, if the wood comes here, that's why we are trying to get out there, get the word out on this stuff, so people can get at least some exposure to it before it does pop up in your jurisdiction, and you're like, well, what the heck is this stuff, so. Yeah, definitely, and I usually tell people too, they're like, how do I know that the engineers are comfortable with this stuff? And I usually tell them, like, luckily right now, there's only a handful of, architects, engineers, contractors who are comfortable designing and putting their stamp and signature on this stuff. Problem with that is, at some point that's going to switch over and you're going to get, hopefully we'll get a lot of architects, engineers, contractors who have never touched this stuff before start to use it as well. And I think then, you're going to get a little bit more of that acceptance throughout there, but yeah, it's brand new. I mean, even here, the first time it was ever used was 1985, really. That's when this stuff was invented. That's not even 40 years. That's nothing in comparison to, the history of building materials. So this is a very new product. And that's why, yeah, there's definitely a lot of hesitancy out there on everyone's part with this stuff. So, yeah, and until we start using it, until, unfortunately, like I said, until a fire does happen in one of these, and we see what happens, how fire department gets in there, how they're able to fight this stuff, how safe it actually is, yeah, there's probably going to be a little bit of hesitancy out there. So, yeah, thanks for that. All right, so here is the plants. Here's how this stuff is getting made. Real similar to glue lambs, basically putting those all in there, gluing them together, putting them through a press. Here's a few more pictures of it. Yeah, you can see another glue layer going on the left there. And then you come out with these big panels at the end. One of the points I was going to make too, before with not a lot of people using it here, the Ascent Tower, Atlanta's getting a 22-story mass timber building pretty soon. There's, and I know at least those two for sure. I think the one in St. Louis that's going to be starting that one as well. All those are actually getting manufactured out in Austria and then shipped over, all those panels. So, so even with that logistics of the shipping and the transportation and all that stuff, these buildings are still ended up cheaper. They're, ending up cheaper. They're ending up on labor savings and time frame of construction. You're still seeing those return on investments for those costs. But as more plants are starting to build this stuff in the US, that's going to make it even easier. These panels right now, really the only controlling factor on the size of these panels, well, the width is based off the press. You can't go any wider than that press that you have, but the length, you can really make them as long as you want. But it's a matter of transporting them to the job site then. How are you getting them? If they're coming from Austria, you have to put them onto a boat, bring them across, put them onto a train, get them into the area, get them onto a truck and get them over to the job site. So, it's that transportation aspect that's really the limiting factor right now on the length of these panels. If you do start getting a lot more manufacturers that are out there putting the stuff together, Now all you gotta worry about is putting it on a truck and getting it out there, which is still, not, you're still gonna be limited on your length, but again, maybe not as limited. So again, so you're making these big, long panels, right? A lot of times most of the time, I should say, they're getting used for floors, but you can use them for walls. This presentation is gonna go into a lot of scenarios if you're using them for walls. And people do use them for walls, but not as much. I will say that, you're mostly seeing them as floors, but we'll go through a whole bunch of scenarios on walls as well anyway, but. So you got these typically, again, floor panels, putting them together. You've got little splice plates then that connect one floor to the next. They can do them in a variety of different ways. I think the Ascent Tower was the one on the lower left there with just one LVL splice plate on the top. I think when we went out there, toured that, they just had one kid that just went down the line, just, with a screw gun, putting those little connectors, the little nails or screws into the splice plate down into the CLT panel, and just did that all day. I think he had 8 batteries lined up on the wall. So, that one runs out, pops that battery out, puts it in, grabs another battery and keeps going. And that's a whole nother thing on lithium ion batteries, but I won't get into that stuff. If you haven't started looking into that, definitely as building officials, fire officials especially, start looking into lithium ion battery storage, but I won't get into that soapbox because that would be quite a while. But panel connectors here, again, every time you see Simpson, they've got new stuff coming out with this because, like Randy said earlier, this is new stuff, right? As people start to use this, as they start working with it in the field, they're coming up with new connectors, new fasteners. How can we make this process even easier, even better? So yeah, every time they're coming up with new panel connectors and things like that. These little clips that they have, like I said, wall to ceiling connections. They can have seismic clips if you're in a seismic zone. We don't really have to worry about that too much up here, but we can do a lot of stuff with the connectors on that. There's some CLT was used in Fitchburg on a project. This is down in Huntsville, Alabama. This was Redstone Arsenal, Army hotel that was used. And this one, you can see they actually did do CLT walls on the exterior and on the interior as well. This was a 4-story. This went up in 12 weeks, but this is just a 4-story hotel. But again, this was one of the first ones that was used, and they were using CLT on the walls. So that's why it's not as impressive as the Brock Commons one we saw before of 18 stories went straight up in 13.5 weeks. This is 4 stories in 12 weeks. But again, they were building up everything on the inside as they went. Because that was a Army hotel, they actually had to go through the U.S. Department of Defense blast loading to withstand bombs and things like that. It passed all that stuff. Here's an elementary school again. This was 8-week assembly for a little addition. You can actually just see it in the upper left-hand corner there, off the back of it. Little 2-story elementary school addition. So again, yeah, a lot of you, you're not going to see the 18-story, 20-story, towers of this stuff, but you might see a 1-story or a 2-story school addition, elementary school addition in your community. So, you can, you definitely can run into this stuff down the line. A lot of universities are using this. Clemson, Michigan State's got a huge program that they're using this stuff with. Pretty much every California school, every Oregon school. Just because, they can bring in their construction, their construction and their engineering schools and their environmental schools, and really studying the environmental benefits of CLT. They're sequestering so much carbon inside these buildings, it's in, I forget how much, this one might have it on there. You see, no, this one doesn't, but on some of these, it talks about how many cars, you're taking hundreds of cars off the road each year by building one of these buildings as well, just with all the carbon that you're sequestering inside the wood that's in these. Well, poll questions All right, again, a couple other projects up in Canada and things like that. Mass timber throughout the country is, or throughout the world is really kind of starting to take off quite a bit. And the last one on there, mass plywood panels. Basically, if you make plywood and you start to, you start putting the veneers of plywood together and you stop at 3/4 of an inch or 7/8 or something like that. Why not keep going to 5 inches or 7 inches? That's what they're starting to do with mass plywood panels. So they're just basically making plywood a heck of a lot thicker and using that as floor panels as well. So you can see some of that stuff going on. They'll actually make smaller panels of plywood that are about an inch and a half thick, you can see. And then move those down into other plywood panels. So they basically just make plywood and then build it up with additional plywood. So mass plywood panels, so again, not covered in the AWC at this time. So that's something that again, you'll look for your ES reports on. But as people start to use this stuff, it's probably going to start getting into the code pretty soon. All right, questions on any of that stuff?
Yeah,
Yeah.
the
Okay.
connectors, are there standard methods of connections for panels, or is it all tested or engineered?
It's mostly all engineered, and we'll talk about CLT a lot more as we go, but yeah, it's basically, again, talking to Simpson, talking to, any of those manufacturers, if you want pre-done connectors like that. But again, a lot of those are more for seismic, applications. Like the Ascent Tower, that Brock Commons one, they're actually using a lot of just hidden connectors within the CLT itself, or the glue lamp beams and columns. So they're gonna come out with, kind of rods coming out of one side and holes onto the other, and you're doing a lot of adhesive connections and things like that that are hidden, or mechanical connections where, that's gonna come through, you put in a lock and washer, a bolt and washer on the other side there. So again, as people start to use these a lot more, they're coming up with different ways of doing a lot of this connection, but it's all heavily engineered. Definitely if you're, for the plan reviewers out there, if you're starting to review any of this stuff, it's for what they make up on the construction side of it, they're doing a heck of a lot more on the design side of it, using all the BIM software and everything. So everything's really heavily engineered. No field modifications on this stuff. The Ascent Tower, I know that came out from Austria. Everything was pre-core, pre-connected. Everything was attached. You're basically just snapping it all together.
So you're not gonna core through for
So
big
yep,
penetration.
all that stuff is all figured in there and pre-cored in the factory. I think, John, do you remember? I think they had to send back like 2 panels or something out of that whole tower. It wasn't very much.
Yeah,
So,
I kind of dropped off at
Yeah.
the concrete phases, so.
yeah,
That's
and,
on, but
yeah, I think it was like 2 or 3 panels was all they had to send back. They had like a 4mm tolerance on getting all those cores in the right spot throughout that building. So, and especially because, your traditional buildings, if you're doing stuff out of steel, you got your steel column and you're pretty much gonna have that same steel column going all the way up your building. With this stuff, the Ascent Tower for sure, they started off, I think it was like 28 by 28 columns at the top, and they're up to 18 by 18 on the top floor, because they can keep shrinking those down as they go up. But then that changes your connections, that start to change your load, you've got a lot more moment on those columns up top there, so you've got longer spans and things like that. So I guess that kind of answers your
It's all
question.
engineered,
Yeah,
basically.
it's basically all engineered. There's not a lot of standard stuff out there that you can just pick off of a calendar, out of a catalog and use. Because every connection is gonna be a little bit different in there. And they want to engineer the stuff down to, to be as precise as they can and make it as easy as they can when they get out there in the field. So, the question, I think, yeah.
height limitations.
Yep, we'll cover that a lot as we go here. Yep. So. All right, if you guys are good on materials that are used in the mass timber stuff, why don't we take a quick, we'll do like a 7-minute break here and come back about 10 o'clock.
Mind folks, we'll be back about 10 o'clock if you want to take a quick break. Thank you.
Got here just. All right, everybody online, we're gonna get started again. All right, so we went through the products that are used. Again, if you have a mass timber building and you have a structure, one of those items that we just went through, right? That's all you can use for combustible materials, at least. Right? You can still use concrete, you can still use steel, you can still use that stuff in these buildings, but you know, if you have a mass timber building and you want it to be a combustible element, it's got to be one of those ones that we just covered. And then every time. There we go. All right. I think it stops because then I click over to the Teams meeting, and then when I come back, my clicker's on the Teams meeting instead of any. All right, so we'll talk about what's in 2015, what's in the 2018. You know, how we build up to what's in the 2021 code. So 2015 AWC, again, you know, we saw this table earlier, but this is where structural composite lumber was added to table 602.4 at the time. Again, we talked about that. Again, that's your LVLs, your PSLs, things like that. So, you know, you've seen these before, but again, if you're going to use them in a mass timber building, they need to meet those minimum size requirements. Cross-laminated timber was actually introduced in the 2015 code. So it was actually brought in the 2015. It was defined and it was basically spelled out where you can use it in type 4, your traditional type 4 buildings. So cross-laminated timber, the definition was added in there. Again, this is the 2015 code. In order to get that in there, there were a whole bunch of ES 119 tests that were done. They actually determined that with one layer of 5/8 type X drywall on there, that you can actually get a 3-hour fire rating out of a CLT panel using the E119 test. You can see it down to 3 hours and 6 minutes. I think they ran that through. And then again, that's where you know, you're starting to develop all those same locations that you can use this stuff in the codes that we talked about earlier. So type 1, type 2 construction, using that on the roof in 1B, and then 2A, 2B. You can use mass timber up there. Type 3, anywhere on the interior, anywhere pretty much except for your exterior walls. And then type 4 and 5, you can use that stuff throughout there. Again, CLT was brought in and basically just inserted into type 4 construction throughout those code sections in the 602.4. One thing to note, this is still in the code, but cross-laminated timber dimensions are actual dimensions in the code. So everywhere else that you're talking about wood, you're typically talking about nominal widths, nominal sizes of the wood, but CLT is actual dimensions. So cross-laminated timber and exterior walls, again, you can use that stuff in here. I'm gonna kind of skip through a lot of this stuff just because, you know, I'll let you know what's in there, but I won't go through the actual code language since it's 2015. We're moving on from that, and you guys can all read the code anyway. So again, cross-laminated timber and exterior walls, some provisions were added in there for that. Wood structural panels in plain floors, cross-laminated timber floors was a section on that was introduced. And again, this is all in 602.4, which is type 4 construction. Roofs, cross-laminated timbers were added into that, minimum of 3 inches thick. Partitions and walls, laminated construction 4 inches thick or 1 hour fire resistance rated. Exterior walls, again, all in chapter 602.4. And that's pretty much it. So, you know, in the 2015 code, CLT was introduced, and then it was basically said, you know, in type 4 construction, you can use it in floors, you can use it in ceilings or in roofs, you can use it in walls, interior and exterior, and that we're using actual dimensions. And so that's sort of that first introduction to it. The 2018 code, you know, the IBC was really starting to put a lot of requirements into chapter 602.4. The type 4 construction was really starting to get huge compared to the other construction chapters. So they pretty much pulled everything out of chapter 602.4 all the construction requirements and moved it all into chapter 23, into the wood chapter. So you can see in here, all that stuff that we just talked about, basically in 2015, it was in 602.4 somewhere. It all got shifted over to 2304.11 somewhere. So basically the same requirements all the way throughout, but just moved to a different section. Let's see, some lumber decking, mechanically laminated decking. That's this stuff was all added into there. So, we talked about that mechanically laminated floors before, and nailing those off. So, some sections, 2304.9 was added. And that's those nailing patterns that I talked about earlier. Again, I'm not going to go through it all because you guys can all read code. I'm not going to worry about that, but just so you know, it's in there. That's where it is. That's where you find it. So if you do run into some nail laminated decking somewhere on a job, this is where all those nailing patterns and requirements came from. It's also added in a new fastening schedule for that as well. Cross laminated timbers in exterior walls was changed to 6 inches thick if you're using CLT on exterior walls. Also in 2018, the code committees really started to look at, are we really talking about type 4 construction or are we talking about heavy timber elements? So they really wanted to, they did a lot of it, going through the code, editing a lot of sections similar to this where, before it might have said type 4 construction, and they said, well, are we really talking about type 4 construction or are we talking about big pieces of wood? If you use a big piece of wood in a type 5 construction scenario, would this still apply? So there's a lot of editing going through, and I don't have them all listed here, but just throughout the code in 2018, they really looked at, do we mean type 4 construction or do we just mean big pieces of wood, basically? So you'll see that throughout the code. Here's a little bit more just where they were editing that stuff and then talking about structural composite lumber. So a lot of this stuff I'm going to skip through. A lot of times we do these classes with a lot of people who haven't really gone through construction types and things like that, but I'm sure you guys are pretty familiar with this stuff. So I'm just going to jump through a lot of that. But the type 4 construction though, if you are using the CLT again, for floors, minimum 3-inch thick. This is type 4 construction. So your wood that's being used on there, minimum 3 inches thick, covered with 1-inch tongue and groove flooring or 4-inch thick CLT. Roof deck, minimum 2 inches thick with 1 1/8 inch wood structural panels or 3-inch thick CLT. And the partitions, 1 hour fire resistance rated, minimum 2 layers of 1-inch nominal board or CLT that's 4 inches thick. So those are your requirements for the panels being used for type 4 construction. Type 3, I'm not going to get into a lot of this stuff. Again, allowable heights and areas, you guys know this stuff, so I'm just going to kind of jump through a lot of that. Sorry if I'm, again, we get a lot of people who don't know how to calculate area, so we kind of keep this stuff in here in case we need to go through some of that. But one thing that I always want to make sure that I note though for firewalls. Firewalls are still any approved non-combustible element except for type 5 construction. And that's still in the code in 2021. It's still in the code in 2024. I don't know of anybody that's looking to change that in 2027 right now, but even if you have these tall or any type of type 4 construction with, heavy timber buildings, if you're in a type 4 situation, it's still a non-combustible wall if you need a firewall. And that's a firewall then that's, separating one building into two, basically. Not talking about fire barriers, fire partitions, none of that stuff. You can use combustible construction in that. But again, if you're in the type 4 building, even under the 2021 code, type 4A buildings, it's all CLT everywhere. If you need a firewall in there, it's got to be a non-combustible firewall. You can use CLT in a type 5 building because you're allowed to do combustible firewalls there, but yeah, so I always want to make sure that I touch on that. Again, how to calculate areas, things like that I'm going to skip through. There were a few things with storage garages in the 2018 code where type 4 construction was permitted into that. So Single story S2 parking garage, underneath the group R. So your pedestal buildings, you can use, type 4 construction down there now. Same thing underneath groups A, B, I, M, and R. Again, pedestal type construction, open parking garages, you can use, type 4 construction down there. And that's kind of it. So again, 2018 was a little bit more just reorganizing, moving everything into the wood chapter. And then going through it, just making sure, are we talking about type 4 construction, or are we talking about big wood type elements? And starting to make sure the codes are coordinated with that. So any questions on 2015, 2018? I kind of jumped through that pretty quick, but all right. Now we'll get into the 2021 code. So again, I brought this up earlier on, but mass timber has nothing to do with conventional light framing. They're both made out of wood. That's about where the similarities stop, right? And in a similar way, type 4A, 4B, 4C, that's your 3 new construction types that are in the 2021 code. We'll talk about those quite a bit. Those are totally separate from your traditional type 4 construction, which got renamed as a type 4 HT. There's heights and areas and things like that for your traditional type 4 are still exactly the same. They just got renamed, but there are a little bit of changes with some concealed spaces in 4 HT. We'll talk about later on, but otherwise, again, 4A, 4B, 4C, and your traditional type 4, they're pretty much different as well. Again, same elements though, but different in the way that the chapters are built and the way that the buildings are put together. So December 2015, ICC got together and they said, hey, let's start to look at, people are using the CLT stuff. They're building really tall, big wood buildings over in Europe. Should we start bringing that stuff over here? So they wanted to look at, let's just put an ad hoc committee together. Let's explore the science and the engineering behind these tall buildings. Let's look at the feasibility. Let's look at, if we did put them in the IBC, what would that actually look like? So they put together a big ad hoc committee on that. And they brought in pretty much everybody, right? So you had, building officials, fire officials, inspectors, plan reviewers, all that stuff. Architects, engineers, they had developers in there, they had contractors in there as well. Some hotel developers, big name hotel chains, they had representatives in there. Fire protection experts, other material industries, and then other construction related professionals. They got pretty much everybody into the room. This is an actual picture of the ad hoc committee at work. And I love this picture because if you've seen any of the code hearings and everything, you've got the steel industry, the concrete industry, and the masonry industry, all three of them sitting there front row at the wood council, at the ad hoc wood committee meetings. So they were all very well involved, and that's why this stuff passed, I think, because, we got them involved early on. And I say we, but I wasn't part of it, but, the ad hoc committee in general. So they came up with 4 different work groups. They had a group working on definitions and standards, one working on fire protection, one working on structural, and then one working on codes. How are we going to write this stuff in? So 82 major issues were investigated, hundreds of reports, and they came up with 6 performance objectives and one kind of unwritten one that I'll talk about as well. But so they had 6 main performance objectives that they came up with. So the first one, no collapse under reasonable scenarios of complete fuel burnout without automatic sprinkler protection considered. So what that means, you got a tall mass timber building, and there's a fire, a reasonable fire scenario inside one of those units. Sprinklers don't go off for whatever reason. We want to make sure that building doesn't collapse on itself. Seems pretty reasonable. The second one, no unusually high radiation exposure from the subject building to adjoining properties to present a risk of ignition under reasonably severe fire scenarios. So now that mass timber building that we have, a reasonably severe fire starts into there, we want to make sure it's not going to jump to a neighboring building and start that one on fire. All right. The opposite for the third objective, no unusual response from typical radiation exposure from adjacent properties to present a risk of ignition to the subject building, again, under reasonably severe fire scenarios. Now you've got your mass timber building, the building next door has a reasonably severe fire in it. We want to make sure that fire is not going to jump over and start the mass timber building on fire. Fourth objective, no unusual fire department access issues. So fire department should be able to come in, do their job just like any other building that's out there. Egress systems are designed, the fifth one, egress systems are designed to protect building occupants during escape time, plus a safety factor. So they wanted to make sure that they had adequate time to get out of that building. And then the last one, a highly reliable fire suppression system to reduce the risk of failure during reasonably expected fire scenarios. Again, that very first scenario was, hey, the sprinklers don't go off. Let's make sure this building doesn't collapse. Their sixth objective is let's make sure that the fire sprinklers don't, not go off. So those are their 6 main objectives. Like I said, they had sort of a 7th unwritten one. And that was whatever they put into the code, they wanted to make sure they had test data that proved what they were putting into that code. They didn't want to make any assumptions and put it into the code. When they got to the code hearings, they wanted, if anybody questioned what was actually going into the code, they wanted to hold up a test report and a video and and everything and all the data and say, here's where we tested this. Here's the proof that this works, and slam that down on the table and walk away. Yeah. That was one of the written objectives, but it was definitely something that was talked about quite a bit in that ad hoc committee. Everything that went into the code had test reports, they had tested it and proved that it works. At the end, the tall wood building ad hoc committee, they determined their package of proposals met all the performance objectives. So all 6 of those scenarios that they were comfortable with it. This was their test facility. We'll talk about that in just a second here. So the fire work group, the firefighters and fire protection engineers and everybody that was in that group, they wanted to prove everything that went in there, basically. They had a lot of test data from other testing agencies that were done, but they wanted to have that kind of that final test data, that final test report for all the different scenarios that they were going into the code with. So they came up with a 2-story condo situation. It was 30 by 30, had a corridor around the outside, a stair tower on the one end. They loaded up with modern furnishings. And again, they did this as realistically as possible. So they put in the sprinkler system, they poured out holes for plumbing, they hooked up plumbing, they hooked up electric, they hooked up everything. They put in furnishings. They had a concealed space in there so they could study the effects on that. So, they wanted to make this as realistic as they possibly could. So the purpose was to perform the test of realistic fire scenarios. This was done at the U.S. government facilities, supervised by the Forest Products Lab staff right here in Madison. So they were pretty heavily involved in this stuff as well. Here's that 2-story condo test situation. And again, you can just sort of see the scale of those CLT panels, those roof panel that's going into place as compared to the worker standing up there. So they ran 5 different tests. So test 1 through 3, they ran with no sprinkler system activation. The sprinklers were still installed, but they just ran it without any sprinkler activation at all. Test 4, they did that with sprinkler activation. And then test 5, that was a scenario then where they didn't turn on the sprinkler system. They waited 20 minutes and then they had a fire truck pull up, hook up to the fire department connection that was outside of it, and then back charge the system that way. So we'll talk about what each of these tests are in a little bit, but this is sort of the duration of the test. They stopped these tests once, the fire ran out basically. So they started a fire in each of these different scenarios, burned it out, and then once the fire stopped, that's when they concluded the test. So you can see kind of how long each of these took, but we'll talk about these each as we go. So here's a little bit more on the 2-story structure that they did. Again, 30 by 30, 9-foot ceiling height. They did 5-ply CLT throughout. And you can see, they did CLT floors and in a ceiling or a roof. And then some of the walls were CLT as well. Right down the middle there, that yellow part, that's some a glulam beam and glulam posts that they put in there. And again, you know, they have the corridor around there and then the stairwell in the back. I mentioned this earlier, but again, the PRG 320 standard that governs the CLT panels, this is using that older standard. So this is using some of the older adhesives, some of the older methods on that stuff. They did steel stud partitions inside there and 1/2 inch gypsum on it. You can kind of see the layout here. So they had a kind of a combination kitchen living room on the left. They had a bedroom on the right with a little hallway, a toilet room in the back, a washer dryer in the middle there, a closet. So, you know, they did the stuff up like it was a real unit. They had a 20-minute rated door to the stairwell, a 90-minute door to the, or a 20-minute door out to the corridor, 90-minute door out to the stairwell. And then they furnished it again. You know, you can see all the furniture that they put in there. In the upper left-hand corner there, that's a concealed space that they put over the kitchen cabinets. A little soffit area just so that they could explore what happened there. In the top center picture, the kitchen cabinets, all the fires were started in that lower cabinet that's sort of facing you right there, right in the corner. But again, you know, build it up with actual furniture so that they could take a look at all this stuff. So fire test 1, that's sort of their base test, right? This is establishing a baseline. So all the mass timber in that building was covered up with 2 layers of 5/8 type X gypsum. And let's see. And we'll watch this fire test. And again, if you noticed in that first, or that graphic where I was explaining the tests or showing you about the test, this test ran for about 3 hours. So that should really take us till about after lunch sometime, when we watch this. No, all right. See if you're paying attention. Again, you can see down here in the lower left that he started up that fire in that kitchen, lower cabinet area there. Again, this is sort of their base test, right? So everything's covered up, 2 layers of 5/8 type X on all CLT throughout. And, but no sprinkler activation, right? So this is just start the fire and see what happens when you start burning this stuff. You get the flash over in the living room there, right around 13.5, 14 minutes on most of these tests. And again, with no sprinklers activating, it does burn up pretty good. But again, you're mostly just burning the contents of the room, right? So we got flash over in the kitchen living room area. At about 17 minutes here, we'll get to flash over in the bedroom. You can see in the bedroom on the right, in the center there, flames already starting to come in through that door. 17-minute mark, we get to flash over in the bedroom. You'll see on the bottom one, the second one from the right, that's the camera out in the corridor. So you can start to see some smoke out in the corridor at about 15 minutes. Again, that's a 20-minute door out to that corridor. The one that's on the lower right, that's the camera inside the stairwell. So no smoke or anything on that one yet. And you can see these things are burning up pretty good. Now they move those, the corridor camera is the one that's right in the center there. The stairwell camera is the one that's on the right-hand side. So about half an hour in, that fire door to the corridor starts burning up. And it drops out at about an hour. All those other cameras kind of went offline for a little bit, but they'll start popping up again pretty quick here. That fire, after about an hour here, that fire is really starting to die out. You can already see, one came back on. And you can start to see it's really just the contents that are still burning up inside there. Yeah, that fire door dropped out a little bit before an hour. And then again, at 3 hours here, we're at the 3 hour mark, everything just sort of burned itself out. And everything turned Felt just fine.
Is there carpet in the corridor or no?
Not in the corridor, I don't think, no.
So basically, the gypsum board was sacrificial for the fire.
Yep. So, and again, that's sort of the base test, right? That we're just establishing a baseline there. So that gypsum was up there. Yeah, exactly. It protected all that CLT that was in there. So again, just a few pictures of it. You can see what that ended up with at the end there. I'm not gonna, that's the only video I'm gonna show you. I won't get into all the other ones, but all 5 videos are on our website. So you can go out there, you can watch those. You can read the test reports. It's awc.com or .org, I'm sorry, awc.org. If I didn't mention that earlier. We actually have a landing page on there for fire, or for mass timber buildings that you can go to and see all that stuff. Fire test 2, similar to fire test 1, right? Covered up everything with 2 layers of 5/8 type X, except they left 30% of the area in the living room and the bedroom exposed. So they had a chunk of the ceiling exposed in the living room, chunk of the ceiling exposed in the bedroom. Ran the test the same way. This one they ran this one for 4 hours, but pretty much looked exactly the same at the end though. But you can see the areas that were left exposed of that wood. They're in the lower center and the lower right. And actually, here's a even better picture. Here's where they took off all that gypsum then, just so they could explore what happened to the CLT. And you can see over here, this is that ceiling area that they left exposed in the living room, and here's that ceiling area that was left exposed in the bedroom. You can see how that charred, right? So, and I talked earlier about the campfire scenario, right? You put that fire, and you got a little fire. You put a big giant log on the campfire, and as soon as that fire burns out, yeah, that log is going to char and everything, but it's not going to keep burning, right? So that's pretty much what happens with this stuff as well. That CLT is going to char, and we can predict how much char is going to be on there, how much of that's going to burn in a given time, and then that's going to protect the rest of that that's in there. So yes, it's sort of a sacrificial char layer that we have on the CLT.
I got a question.
Sure.
There's the A, B, and C.
Yep.
Right. As far as protection. B is allowed to have 20% exposure. I see the testing here is listed as 30%. So how did they change? Because this is an expensive test, I mean,
Right.
let's be honest. How did they come up for code language to 20% for a type 4B heavy timber versus the 30% the testing? What justified that?
Basically, a compromise to get it through the code quicker and easier. They tested 30, they were confident with 30. And then that's when some people said, well, do we really want to go to 30? Or do we want to pull it back a little bit and only allow 20%? Just so we make sure that we get it into the code and it's smooth sailing through. So yes, a lot of code development is compromise and just sort of a, what do we know we're not going to get as much opposition with? So people are very confident with 30, and actually you'll see later on what's coming in the 2024 code. I'll get into that, which is even beyond the 20%, but and that's in the 2024 code. But yeah, that's sort of how they tested at 30, they scaled it back to 20 just to get it in the code essentially.
So that picture, is that from the first level? Are we looking at the ceiling in the first level to, which would be the floor in the second level, or is that the roof level? That
Fire test 2. Yeah, this was up on the second story.
So that would be
This one.
the roof structure.
Yeah, basically the roof ceiling assembly then.
How far was the char in the panel?
Yep. That much.
And is that,
So-
is that panel salvageable, or does it have to be torn up and redone?
Yep, great question. So here, let me talk about this first. All right, so when they first cut out that section then, all of this was basically filled in with char, right, down here at the bottom. They scraped it off just so that they could measure how much char was in there. Again, these were 1 3/4 or 1 3/8, I'm sorry, laminations. So you can see it went 1 1/4 into it, something like that. Again, we'll run into that later on where we talk about how much char, through testing that we have. You can see from here over is where the 2 layers of 5/8 we're on there. I do just want to point, as long as we're on here, you can see if there is a little bit of char on that beam, you know, where the fire would come up and go around it, but for the most part, all that CLT was pretty well protected in there. Now, on our website, yes, we do have some engineers and scientists, people way smarter than me. They have gone through and come up with a repair method that we actually have that on our website as well, where yes, you can cut out the affected laminations on there. So just basically they take a saw, cut that into the next lamination that's on here. So they would just cut out this bottom lamination here all the way across. And they came up with a glue and screw method that basically to put a new lamination up onto there, pull out those screws then, because they don't want that metal in there, because that's going to affect the fire properties of it. But they've been able to do that, and then they actually went through, they did fire testing on it again. Yeah.
Sorry to hold you up. We're having an issue on mine. They're getting the presenter's view.
Oh, okay.
Change stuff.
Yeah, let's see.
They're getting-
Let's see, did that change it? All right.
Thank
So yeah, so they went through, figured out how to basically put a new lamination into there, glue that all up. They ran the fire tests on it and the structural tests on it as well. And they can prove that it has the same structural properties and fire properties as a new one. So yeah, if you do have a fire in a building, you know, the Sun Tower, 18 stories on the 3rd story of CLT, they get a fire. They don't have to take everything apart. They can come in there, cut that out. And we've got, like I said, some videos and reports on our website on how to do that. So, yeah.
So they analyzed all of the heat affected the glue and the portions that weren't charred.
Yes. Yep. And actually, I was just going to talk about that a little bit here. So you can actually see a little bit of delamination down here in this bottom corner, where that one ply is starting to peel off on there. Again, this was using that older adhesive. So with the newer adhesive, I haven't seen it personally, but I've been told that you don't get that little delamination there as you start getting closer to the plies. So, but yes, yeah, they went through, they tested this thing up every direction that they could, just to make sure that kind of what's left, you know, that top 4 plies on there, that's still good and solid and structurally sound, basically with it. Gotcha.
So when they sister in that chart area, you said you do the whole
Yep.
laminate piece, so if it's a 40-foot run, you do the whole 40, or
There-
you sister it into a good portion of the,
Just where it's charred.
just
Yeah.
where it's charting?
Yep.
Okay.
Yep. Yeah, they're just cutting that out. Yeah, so if this whole thing is over and the fire only took out this little 4-foot section, they're just gonna come out probably a 5-foot section, just make sure they catch it all. Yeah. All right. All right, so fire test 3. Same thing, or similar things. So now what they did was they left 2 CLT walls exposed, the whole wall's exposed in there. Again, though, you know, 2 layers, 5/8 type X covered up everything else, but one wall in the bedroom and one wall in the living room, they left those 2 walls exposed during the fire. And again, yeah, as Randy would probably point out, in the code, it's 40% of the area.
It's 20.
For walls, it's 40.
All right,
Yeah.
okay.
Yeah, so walls, it's
20 for the ceiling.
Yep. But yeah, so the walls is 40% of the room. Here they just left that whole wall exposed. Again, kind of cranking it down a little bit just for being able to get it through. So fire test 3, pretty much the same thing, right? You had the walls, they were charred at the end. Fire test 4. They actually left all the CLT exposed in fire test 4, so they didn't put up any gypsum covering up the CLT at all in fire test 4, but they let the sprinklers run. And you can see down there in the bottom, center picture, that's all the damage that was done, there, just the cabinet itself got burned up. And then the, sprinklers activated and put that fire out right away. But you can see everywhere else, the CLT was left exposed. And then fire test 5, again, they waited 20 minutes, they put this, they set the fire, waited 20 minutes. They actually had a fire truck come over, hook up to the fire department connection that they had. Back charge system, that took about 3 minutes. So actually at 23 minutes is when the sprinklers activated. And in about 7 minutes, that fire was put out as well.
Question.
Yeah.
For the water, the sprinkler and the other one that you're just talking about, did that affect the materials at all from the water?
The water, I've been told no, but I haven't really seen, personally, I haven't seen any reports or data on that. I've been asked that before. I've asked the question and they said, no, it didn't affect it. But that's not really the best answer, so.
Which are building in a rice bag?
Yeah, exactly. So I've been told no, but I'm not confident in saying that for sure, but I'm sure it would have been brought up by now.
They probably got some sort of preservative or something on that one too.
Yeah.
In the factory.
Yep.
So it's gonna
Yep.
retard that plus.
Right. But not just that, well, and there's sealant that's required between the CLT panels and stuff. Usually on the floor, you're gonna have some gypfree. I'd be more worried about, having that come down to the lower units as well and start going throughout the building. Hitting some of the penetrations and stuff, but yeah, I've been told that it doesn't have an effect, so. All right, here's that results log on this. So again, you can kind of see, right around that 11.5 to 13.5 minutes to get the flash over in the bedroom, in the living room, 17 minutes flash over in the bedroom. Flames out in the hallway, right around that 25 to 30 minutes. In fire test number 3, they actually installed that 20-minute door wrong. So they only got 13 minutes out there. Leave it to government. And then the compartment door failed in about an hour, half hour on the one where they put the door in wrong. And then you can see the sprinkler activation. So again, actually all the tests were terminated with no regrowth of that fire. It says test 2 and test 3, but those ones went to 4 hours. They just wanted to let those things run out as long as they could. But all of them were shown with no regrowth. Again, that's just sort of some of the other recap of some of the other stuff. The numbers on here really don't matter. What this is a graph of, this is your heat release data in kilowatts, by time. But what I like this slide and the next one about is basically, the black line that's on there. That's what the engineers and the scientists all predicted the heat release would do. And then the blue line that's in there, that's what actually happened. So their predictions were pretty darn close with what they thought was going to happen is what actually did happen. And then here's another one with temperature of the ceiling gas. Same thing. The black line is what they predicted. Blue line is the actual recorded data. And again, they knew pretty much what they thought was going to happen is what happened.
Did they know exactly what the rooms were loaded with? Or did they take like an estimate of what a typical
When they did when they
heat release?
predicted the scenarios.
Yeah.
They would have put in whatever the heat or the room load would have
Which
been
happens
into
in the
that.
furniture.
Yep. So each of the new construction types were based off of some of those tests. The first test is going to equivalent to or be real similar to 4A. Test 2 and 3 are real similar to 4B, and then 4 and 5 are real similar to 4C. And again, they went through all of those. Again, all the fire test reports, the videos, all that stuff on our website, awc.org. You can take a look at that if you're interested. So based off of that, those testing, and they did a whole bunch of other testing too, you know, like I said, they looked at a whole bunch of other ones, but this was after they had, you know, kind of narrowed this thing down to this is what we want that building to actually do. Then they ran those tests just to prove that they were gonna be good with those, but they went through 17 different code change proposals, new heights, new areas, new construction types, safety during construction, exterior wall tests, things like that. All 17 proposals were approved. And if you want to go through and you know, on the ICC's website, if you go to CDP Access, you know, you can still watch all the hearing videos. You can read all the code change proposals and all the background data and everything that was submitted. All that stuff's out on the ICC website. We have links to it on our website as well, if anybody's interested in going out there, watching the videos, seeing the testimony on this stuff.
Are you getting similar results from NFPA's building code standards?
Yep. Actually, NFPA 5,000, you can actually do bigger and taller than what's in the IWC. So, yep.
That's more of a fire department.
Yep.
Generated.
And they actually don't have the equivalency of a 4B here. They basically have the equivalency of a 4A and a 4C. So they pretty much have either cover it all up or don't cover up any of it. And those are their two options essentially of what they have in there. So, yep. But yep, NFPA 5,000 has this stuff in there as well. All right, questions on any of the testing procedures, all that type of stuff, the ad hoc committee? All right. So what did we come up with then? What were those 17 code changes? Well, first off, like I said, they wanted to go through and do some definitions. So they had the definition for mass timber, that's structural elements of type 4 construction, primarily of solid built-up panelized or engineered wood products that meet the cross-sectional dimensions of type 4 construction. So again, that's at table 230411. You have to meet those cross-sectional properties of that table still to be considered a mass timber element. And then they have non-combustible protection for mass timber. The non-combustible material in accordance with 703.6 designed to increase the fire resistance rating and delay the combustion of mass timber. Again, you know, in those test scenarios, they're putting up the 2 layers of 5/8 everywhere. That's your non-combustible protection, right? They want to make sure that, yes, you know, we know that the CLT panels can withstand fire, but they also want to have, you know, some non-combustible protection on there just to give it, to increase the fire resistance rating and to delay the combustion. So 722.7 is the fire resistance rating of mass timber. And so that's where you get into that non-combustible protection. And the fire resistance rating of the mass timber elements shall consist of the fire resistance of the unprotected element added to the non-combustible protection. So again, the CLT itself, or even the glulam beams, the glulam columns, all that stuff, there is, you know, fire resistant properties incorporated into that, right? So you add whatever you get out of that, plus your non-combustible protection that you're going to put around that. And so how much non-combustible protection are you going to have? Well, it's typically going to be 2/3 of what's required. You need in non-combustible protection. So table 722.7.1, parent 1. If you have a 1 hour fire resistance rated construction, right, you need that wall to be 1 hour rated. At least 40 minutes of it has to come out of non-combustible protection. If you need 2 hours, if you have a column and you need a 2 hour rating on that column, 80 minutes of that 2 hours has to come out of non-combustible protection. And then 3 hours or more, again, 120 minutes has to come with non-combustible protection. And that's nice, you know, it's all in multiples of 40. I wonder what the code's going to tell you about that. So we'll get to that in just a second. So the rating in minutes contributed by the non-combustible mass timber elements shall be in accordance with 703.6. So let's look at 703.6. That's basically going to give you 2 different options, right? You have a performance option or a prescriptive option for coming up with that non-combustible protection. You can do a performance option and go get it tested, which basically walks you through a ASTM E119 test, which basically says, you know, run a test with the element unprotected. So put some CLT in that test, burn it down, see how long it takes to burn through that. Then do assembly two, where you're gonna put that non-combustible protection on there, burn it through again, see how much time it takes to burn through that, and then subtract the time. So if the CLT panel itself takes 3 hours to burn through, you put something on it, and now it takes 3.5 hours to burn through, all that, whatever you put on there is gonna be half an hour. Makes sense, right? But ASTM P119 tests are you do have that option in the code. You can, send it out, get it tested with and without that non-combustible protection on there. That's your performance method. You're also given a prescriptive method. And that tells you that 1/2-inch type X gypsum is going to give you 25 minutes. And 5/8 type X gypsum is going to give you 40 minutes. And okay, pointed out a second ago, we've got 40 minutes, 80 minutes, 120 minutes in that table, right? In 702 or 722.7.1 parent 1 is going to be 40, 80, and 120. So that's 1, 2, or 3 layers of 5/8 type X. Yeah.
So does table 722.7.1.2 now allow for the prescriptive method to be greater than a 1 hour assembly?
What do you mean?
Thought my understanding was, maybe it's in the 2015 code, but that this table is utilized for assemblies up to 1 hour.
This table isn't in the 2015. This was new in the 2021.
Okay.
Yes, you are correct.
A
That
wood stud wall.
statement is correct for 2015. You are limited to 1 hour for a prescriptive assembly.
For a wood stud wall.
Yeah,
Yeah.
one stud wall, correct.
Yes, yeah. Now I know what you're talking about. Yep. Were you just answering that? Okay, yep. Sorry, yeah. You are right in the 2015, yeah, the 2021 though, and this is again just for mass timber elements. That's all we're talking about here is your non-combustible protection on a mass timber element. So again, if you have a 1 hour wall, you need 40 minutes, 2 hour wall, you need 80 minutes, 3 hour. And wall or column or beam, whatever element you have. 3 hour or more, 120 minutes. So each of those are multiples of 40. So most of the time, everybody's just gonna throw on 1, 2, or 3 layers of 5/8 type X on there.
Does that apply to mass timber elements outside of type 4 construction, or is it limited to?
It's a good question. Yes, yeah, that would. So, yeah, anytime you have a mass timber element. I believe, let me double check that on the break. I'll check through the code and answer that one after our next break. I want to make sure on that, because yeah, if you have a mass timber element in a type 5 building and you need it to be 1 hour rated for some reason, I actually think you could leave it exposed, but let me try to double check that one. All right, so now we know we have that prescriptive method. If you're going to use that method, there are a list of rules on how to use that gypsum as a non-combustible protection. So your screws have to penetrate the mass timber by 1 inch or more. The screws have to be placed no more than 12 inches on center in each direction from each other. And also, if you have 2 layers on there, it's not up on the board here, but it's in the code. If you have 2 layers on there, the screws from one layer to the next layer have to be 4 inch, have to have 4 inches of separation. How you're gonna check that, I don't know. But again, if you come in there after 1 layer, see where they're at, measure the first one off the wall or something and make sure that they're all 12 inches down. Second layer goes on, now you're coming off. I don't know how you're gonna do it. I will admit that, but it's in the code. It's their responsibility really to make sure that they meet that. So 12 inches on center in each direction. Screws at panel edges between 1 inch and 2 inches from the edge. Panel edges offset 18 inches in each direction. Stair step profile on wall to wall or wall to ceiling scenarios. We'll take a look at that in a second. And then covering up joint compound. There's another one that's on there too. When you have a 3rd layer, you are permitted to do some hat channel in there between the 2nd and 3rd layers. You don't have to, but it's given as an option. Otherwise, all the 1st layer and 2nd layer have to be tight to the mass timber. It's probably hard to read for those of you in the room. Maybe you can see it better on the side screens there, but This is just sort of a graphic of, you know, what's all there. The black lines are the first layer on there, and then that dotted line, that's the second layer of gypsum that's going on top. So you can kind of see the X's go with that second layer, the dots go with the first layer. But that just sort of, you know, lays out that you have your 12 inches on center from, you know, screws in each direction. Per layer, 4 inches from between the two layers. Your 18 inches of edge panel distance offset in each direction. And then you can see that where you have two walls coming in on the right-hand side there, that stair step, right? So you can't just do layer on one wall and then layer on the other wall. You do a layer on one wall, layer on the next wall, layer on the next wall, layer on the next wall. So you get that step function in that intersection like that. Here's a CLT floor to a wall. Same thing though. You get that step function in the corner. So on the ceiling, you're gonna do one ceiling layer. If you need 2 layers of gypsum, you know, 1 layer on the ceiling, layer on the wall, another layer on the ceiling, another layer on the wall, right? You're gonna keep, you can't just do ceiling, wall. Right? One thing that I find very strange, but again, everything was tested, everything was done, you know, and examined and everything, and this is how they came up with it. But on the right-hand side here, this is an exposed area of the ceiling, right? From here over, you can see the edge of the 2 layers of gypsum there. All they're putting is just a piece of corner bead on there. To me, I would think they'd want, you know, a few extra screws on there, you know, something to really seal that gypsum in there so that, you know, so that the fire can't kind of creep down the side of that gypsum. But again, it was tested, it was shown that this works. And so that's how it went into the code. Personally, I think it seems like it should have something else there, I guess, but it doesn't, so. That's how you can do those edges then if you do have exposed areas. Exterior surfaces, 12 inches on center. And 6 inches on center for 12 inches on center in the field, and 6 inches on center on the panel edges for gypsum on the exterior surfaces of exterior walls as well. All right, with that, why don't we, before we get into all the heights and areas and all that good stuff and fire resistance ratings, let's take another 7-8 minute break here and we'll come back at 11 o'clock then.
Online folks will be back about 11 o'clock.
It'll allow. The 2021,
Just to clarify, the 5 fire sets, they use the same structure.
Yep.
All 5 times.
Yeah.
and
And then actually, yeah, I'll tell the group when we get back to, yeah, then they took that structure then that they did, they moved it over to Yale and they used it in a building there actually after they were done with it even.
And they'll start probably like the 2024 starting September. I don't know, they'll do it in. But. So I don't know what the final action is for the next side.
Yeah, I guess so.
Especially I can build over anything I said, but I don't know. Like, I'm seeing here, so I was questioning the exposure. Yeah, I started. I did 20. And that makes sense. You don't know what they're getting themselves into. What's the point? I got a fire. Now. Points. Fire department is very apprehensive about yes, Milwaukee. buildings. Like the. Issues. And the city wants to see us like, bank for class three years. It's the state of warning. It's a big place. And we have some. And the United States down there, they're now. It's like this. These buildings. There's four.
Yeah, are you done?
That's it, just it is. Already don't think about it, 25%. He said the petition to the city manager works at the Nobody knows that. Of that one village, of city. I don't know where it is. But there's a place where it's shut. Yeah. I said, petitions, I don't know. But you know, it was.
Yeah.
If anything's fine, but I said, much better than the really strong. Yes. Nobody knows there. Again, with some choice, you know, I think about wedding
It takes for somebody. Yeah. Just like.
States into the 20 minutes.
I didn't find that.
Yeah. This is the very fast. We do it for and you think you're but you kind of do is usually just you get into this well. Experience knowledge and they're
It starts to get a little bit of difference.
It's the building mass. It was the percentage.
B.
Yeah, percentage of coverage is really. Because the.
All right, let's get started again.
We still having hearings, so it was, there were the preemptions.
All right, so we had a question earlier about the non-combustible protection. And actually, as soon as I opened up the book, then that's when it hit me. So again, it all comes back to definition. So that's non-combustible protection for mass timber. The definition of mass timber is elements in a type 4 construction building. So when you go back into chapter 23, it talks more about heavy timber and things like that. So heavy timber is sort of the generic term that can be used anywhere for larger pieces of wood. Mass timber is very specific to type 4 or elements that are. So, yeah, so all that non-combustible protection for mass timber is when it's used in type 4 construction. So hopefully that answers that one. And then actually I did also another question came up on the break. That test facility that I showed you earlier where they ran those 5 tests, they did use that same building basically for all 5 tests. So then they pulled out a couple panels when they, had those really bad char ones. So they pulled out a couple panels, put in some new ones for that. But once all 5 of those tests were done, they actually took that building apart, moved it over to Yale, and it's being used in a building there. So, they kind of reuse a lot of this stuff because it's still good. It's still very valid and usable. So, there's even we probably won't get to it today, plus it's kind of irrelevant for Wisconsin, but there's a shake table test. When we get into some of the seismic stuff at the end of this presentation, but like I said, we probably won't get to that. But they built a 6-story building on top of a shake table out in Japan. Shook it all up, tested out all their best earthquakes out there. They actually took that down, then moved it over to France, reconstructed it, and used that as an apartment building out in France then. So this stuff it's pretty reusable and everything. So it takes a lot to break this stuff. So. All right, back into the presentation here. So fire resistance ratings, everybody's pretty familiar with this table, right? Table 601. So now we've got in type 4A, 4B, 4C. And so what fire resistance rating do you put on this stuff? So what they did for 4A is basically just copied over type 1A. And when I say a type 1A building to everybody in this room, you're thinking of hospitals, you're thinking of these buildings that have a lot of fire resistance rated elements to it, right? You've got your 3-hour primary structural frame, your 3-hour interior and exterior bearing walls, your 2-hour floors, and your 1.5-hour roofs typically, right? So all those exact same fire resistance ratings in 1A were moved over to 4A. It's exactly the same thing. So when you think about a 1A building and that level of fire protection that you have in a 1A building, that's the same level of fire protection that you have in a 4A building. For 4B, 4C, same thing, only they copied over the 1B buildings, right? So you've got 2-hour structural frame, 2-hour interior, exterior bearing walls, 2-hour floors again, and a 1-hour roof. That's what they just cut and paste right over to get a 4B and a 4C. So again, when you think about a 1B building, that level of fire protection that you have in there, that's what you're getting in 4B and 4C. Because you're on the 2015, you probably know this is table 602. In the 2021, though, it got moved into the exterior wall section 705.5. So it's now table 705.5. But this is your fire resistance rating based off of fire separation distance, right? And you can see here from 5 feet to 10 feet, you got a separate category in there for a 1A building. Again, 1A fire protection is equivalent to the 4A fire protection. So they brought over a 4A, and then from 10 to 30 feet, you got the 1A and 1B have a certain level, and then 4A, 4B are brought into that. They didn't bring in 4C. I don't really know why, but everything else, 4C was the same as 1B, but not for that one. All right, so in the code though, again, I've said this a few times with 3 new construction types, 4A, 4B, 4C. No changes to the height and area, and general requirements of the, old type 4 buildings. They did rename them as 4HT. There are some things we'll talk about a little bit later on that you can't have concealed spaces in a 4HT now, the old type 4s. So that's pretty much the only significant change I would say to the old type 4 buildings. All right, so types construction comparison. 4A, 4B, 4C, the 4A, 100% non-combustible protection on all surfaces of the mass timber elements. So when you have these 4A buildings, you're not going to see wood anywhere unless it's like a finished material, but all the mass timber is going to get covered up with 2 layers of 5A type X everywhere. Type 4B, 100% non-combustible protection on all surfaces of mass timber, except for some limited exposure areas. If you remember those fire tests 2 and 3, we left some ceiling areas opened up, we left some wall areas opened up. That's where you get into the 4B. So almost all of it's going to get covered up, but we're going to leave a couple areas exposed of that mass timber wood. And then 4C, 100% exposed mass timber, with the exception of shafts, concealed spaces, and then the outside of exterior walls. On all these, the outside surfaces of exterior walls are always going to get covered up on mass timber elements. Which is again, you know, I kind of mentioned that earlier. That's why a lot of times you're not going to see CLT panels on walls, right? But you're going to get your typical curtain wall framing on the exterior walls. But if you do have CLT panels on the walls, the exterior side of the exterior wall is going to have at least 1 layer of 5A type X on it. And that's for A, B, and C. Permitted materials, so structural building elements, non-load bearing exterior walls, non-load bearing interior walls. So pretty much any structural element and all of your wall types, you can have either mass timber or non-combustible materials. So what you're not going to see on there, again, I mentioned this earlier, you're not going to see 2x4 stud walls anywhere in 4A, 4B, 4C. You're not going to see floor joists, typical 2x12 floor joists. You're not going to see anything like that. You're not going to see, light frame trusses, anything like that. You can have non-combustible elements. You can do steel studs with drywall, but no smaller wood pieces for structural building elements, non-load bearing interior walls, non-load bearing exterior walls. All that stuff is you're not going to have studs on there.
Does that include FRT?
Yep. Shaft and exit enclosures. Once you get up over 12 stories, and that's that bottom line there, above 12 stories, 4B, 4C, that wouldn't be permitted, but for a 4A, once you get up over 12 stories, your stair shafts and exit enclosures, they're going to be non-combustible materials. So typically, masonry or concrete. But otherwise, up to 12 stories. For type 4A and 4B, you're going to have 2 layers of 5A on the inside and outside, or equivalent. And then on the 4C, you're going to have 1 layer of 5A type X. Unless in a 4A, if you do need that to be a 3-hour, then you'd have 3 layers on there. Again, just another little recap, but your 4A non-combustible protection, at least 2/3 of the fire resistance rating. Taller buildings, but again, no exposed mass timber. Type 4B, you've got some exposed areas, and then 4C, everything's. You can see that beautiful wood everywhere in a 4C. All right, so again, I said this too much, but again, you're not going to get too many CLT exterior walls, but if you do, here's what those are going to look like. So in a 4A exterior wall, it's again, a 3-hour, if this is a bearing wall, I should say, a 3-hour bearing wall, an exterior bearing wall, you're going to have 3-hour fire resistance rating. 2/3 of that has to come from non-combustible protection. So you're going to have 3 layers of that 5A type X. 1 layer of 5A type X on the exterior side of the exterior wall for a 4A. And then again, you can have that furring channel between the 2nd and 3rd layer. One thing to note on there, the 1 layer of 5A type X is required on the exterior side of an exterior wall. But remember, if you are within 10 feet of a property line, or your fire separation distance is less than 10 feet, now you have to worry about fire exposure coming from that other side as well. So you may have to add some additional layers on that outside of that as well. But typically, you're gonna have just that one layer on there. And then that's kind of what that looks like. Again, everything's covered up with gypsum. Floors, they are required to have a 1-inch non-combustible material on top of the mass timber. That's different from that non-combustible protection that we were talking about. This can be any non-combustible material. So a lot of times you can get 1-inch gypcrete on the bottom. You could do, 2 layers of 1/2-inch cement board, like a Durarock type product. You could do something like that on the floor. You can do stuff like that. So it's not specified as much. It's just at least 1 inch of non-combustible topping. And that's going to be in the 4A and the 4B. You don't get that in the 4C, but. Here's an exterior wall for the 4B. Again, if it's a bearing wall on the exterior, you're going to have 2 hours of fire resistance rating. And again, you can have some wood exposed. Now, keep in mind, with this, you still have, this is still a 2-hour fire resistance rated wall, right? So up here, you've got the 2 layers of 5/8, which is going to account for 80 minutes of that. So 40 minutes is going to be, coming out of that CLT up in here, right? So you're going to have 40 minutes of a protective char layer coming out of that CLT. If you have an exposed area, now all 2 hours of that still has to come out of that CLT panel, right? And we'll take a look at how much that char layer is and stuff like that a little bit later on in the program, but just kind of keep that in mind that if you have those exposed areas, you still have that fire resistance rating of that wall or that column or that beam. You still have to make that, a little bit oversized with that protective char layer. And then a 4B, again, you can see a little bit of the wood popping up in here, but mostly covered up with gypsum. And again, that 1 inch at the bottom there, 1 inch of non-combustible material on top of the mass timber floor. Now we talk about some exposed layers or some exposed areas. And what does that actually mean then for a 4B building? So 602.4.2.2.2, hopefully you all got that covered. Unprotected portions of mass timber buildings. This is in the type 4B section, right? So this is just for type 4B. 4A, you're not going to have anything exposed. 4C, everything can be exposed. But 4B, where can we expose you? So there's actually 4 different scenarios of where you can have exposed mass timber elements in a 4B construction. So number 1, unprotected portions of mass timber ceilings, including the attached beams, shall be permitted to have an area equal to 20% of the floor area in any dwelling unit or fire area. We'll break that down. So 20%, like Randy pointed out before, the test, yep, they were at 30%. They kind of cranked it down a little bit to actually get it into the code. So they put it down to 20%. So 20% of the floor area can be exposed in the ceiling. Now that's of the dwelling unit or the fire area, which means, if you take this building, I'm going to assume we're all on one big fire area here for at least for this floor, that this isn't really broken up too much. So you could, if this was a mass timber building, you could walk into here and conceivably this whole entire ceiling in here could be exposed because you're 20% of the fire area. You're not 20% of the room. Similar, if you have a dwelling unit, right? 20%, you could almost have that. You could probably have that whole bedroom exposed because you're at 20% of the dwelling unit. And that dwelling unit is going to be a much larger floor area than just that room. So you could break it up and do 20% in each room if you want to. That would still, equate out to 20% of the dwelling unit. But you could also save that up, make it all up, and put it all into one room and have, one big room with that whole ceiling exposed. Make sense?
I got a question. It talks about in any dwelling unit or fire area.
Yep.
Let's go down the route of a residential facility.
Yep.
Right? 2nd, 3rd, 4th floors are all residential. We can probably have some corridors, right? Let's go back down to the 1st floor where you've got mercantile, business, who knows?
Right.
It's 20% of the fire area.
Yeah.
So is there any, it doesn't appear to be any distinguishment of 20% on the mercantile versus assembly, and I'm going to push the lever and say corridor,
right,
doesn't matter,
right.
okay?
Yep, that's how they went into it, so. But to help with that, the 2024 code specifies this a little bit more, and it says in any single floor of the dwelling unit or single floor of the fire area. So, but the way that it's written right now in 2021, yeah, you could bank up that entire building if it's all one fire area, or, you know, or if you have a 2-story dwelling unit, you know, or even 3-story, if you got a garage underneath with a, you know, a little walk up to the living room and then a loft area with some bedrooms. You could have 3 stories of that dwelling unit that you put everything, you know, you're taking 3 stories of area and putting all that into one space. So again, in 2024 code, they do clarify and they say of each floor, a couple times in that. So now you're just taking, you know, 20% of this floor area and putting that in there. Or the floor area of this floor, I should say, of that dwelling unit or that fire area. But yeah, if you're gonna combine other stuff, yeah, you can certainly do that. You can take the corridor space out in the hallway, utility areas, elevator equipment room, you're looking at the area that's in there. Yep. And then again, keep in mind that that's also attached beams, it says, so, you know, again, we're in a mass timber building. And we've got a beam that's tight to the ceiling in here, because this is a CLT panel in here, and we've got a beam that kind of cuts right through the middle of this. That's attached, so that's gonna get covered the same way that the ceiling is, other than you can leave that exposed, and that can count to your 20% then. All right, so again, you know, you may only get, you know, maybe a little bit of the ceiling, but you want that beam exposed, or maybe there's 2 beams through here. And you want both those beams exposed, well, you add up the area of those beams and that's your 20%, then you're not getting anything on the actual ceiling itself because you left those beams exposed. We'll see some pictures of that in a little bit, but. So that's option 1, right? Throw it all up in the ceiling. Option 2, portions of mass timber walls, including attached columns, are permitted to be exposed shall be limited to an area of 40%, again, of the floor area of the dwelling unit or the fire area. So now you got 40% in those fire tests. Yeah, they just said, we're just gonna take this whole wall and leave it exposed. But now they shrunk that down a little bit and they said, all right, let's just make it 40% of that wall. But again, you know, you can take the floor area of this entire fire area on the first floor here and throw it all into this room. You couldn't, because there's some other limitations, but you can do like this wall and that wall and have those 2 walls totally exposed, because that's your 40% of your fire area, right? So option 1, throw it all on the ceiling. Option 2, throw it all on the walls. Option 3, and actually with option 2, again, that's also columns that are up against that wall. So this is a solid wall and this is a column sticking out, and you want this column exposed, that goes into your 40% then, right? Option 3, unprotected portions of both walls and ceilings, including attached columns and beams, shall be permitted in accordance with 602.4.2.2.3. So that's going to be a ratio. So option 1, throw it all on the ceiling. Option 2, throw it all on the walls. Option 3, do some in the ceiling and some in the walls, and we'll take a look at that ratio in a second. But it's basically a ratio not to exceed 1 of, you know, what you want to do divided by what you can do on the ceilings, what you want to do divided by what you can do on the walls. You gotta be equal to or less than 1, but we'll take a look at that in just a second here. So your option 3, any mass timber columns or beams that are not an integral part of the walls or ceilings shall be permitted to be unprotected without restriction. So again, mass timber building, right here in the dead center, we've got a column. You don't have to protect that if you don't want to. It's not an integral part of it's not up against the walls, it's not up against the ceiling. You can leave that exposed. Same thing if you had a beam that kind of cut through here 5 foot, 5 foot high. I don't know why you would, but that could also be non-protected, right? So those are your 4 options. Maybe in an atrium situation, you might get into something like that, I guess. All right, so here is 20%. For these next few pictures, you got to kind of assume that what you're looking at here is the entire fire area or the entire dwelling unit, right? We're going to assume that beyond these walls, that's either a different dwelling unit or a different fire area. But 20% of the ceiling, you can have that exposed, right? You can split that up into a couple different ones. This is, two areas here of 10%, right? That's about half in each. 40% of the walls, they split this up into two already. And then here's that mixed unprotected areas of 602.4, 0.2, 0.2, 0.3. So again, the first part here is your ceiling area. You got your ceiling area and then your wall area less than or equal to 1. And again, that's your, basically what you want to have exposed in the ceiling divided by what you're permitted to have exposed in the ceiling, plus what you want to have exposed in the walls divided by what you're permitted to have exposed in the walls has to be equal to or less than 1. So if you're going to be at 50% of the ceiling, 50% of what you're allowed on the walls, that would equal 1, right? We used to have some other ratios like that, when calculating areas of mixed use buildings and stuff in the code, right? So I think we're all familiar with that idea.
I got a question, back to that equation.
Yep.
Now, previously, it was taking 20 and or 40%, depending if it's ceiling or wall.
Right.
Of the floor area.
Mhm.
Yet this equation identifies the ceiling as a ratio to the ceiling, right, on the left side, and of the wall on the right, whereas before it was all based on the floor.
Right. I think it's the ceiling area conforming with exception 1.1, so that would be your ceiling area that you're allowed to have by exception 1.1.
Okay,
So that's
all right.
Yeah. And then your wall area as permitted by 1.2.
That makes more sense. I was confused in how they were getting there.
Yeah. Yeah, your area conforming to exception 1.1, and then your wall area conforming to exception 1.2, so, yep. So here's what that kind of looks like if you want to do both of them in the same room, right? We split that ceiling area up into two, so we got 50% on the ceiling, 50% on the walls, we can do that. I'll add in some beams and columns. So again, if you have that integral beam, that integral columns, they're up against the wall, they're up against the ceiling. They have to be protected the same way. I don't know if you can read that, but you've got 6 foot by 30 foot exposed ceiling area there. All right. You've got 180 square feet of ceiling area exposed. Now, this and that, it looks like that ceiling area got a lot smaller, but if you go by the dimension on there, it still says 6 feet. So I don't like that graphic. I wish that they would have made those the same, but so you still have that same area exposed on the ceiling. And now you've got a column that's right there, dead center of the room. Again, that column, if it's not attached to up against the walls of the ceiling, you can have that exposed at all times. So you can always have that column right there in the center of the room left exposed. Now here, we're down to, again, I don't know if you guys can read this, but 2 feet of exposed ceiling area, right? But the other, we had 6 feet before, right? So now we have 2 feet of that ceiling, and so that other 4 feet of exposure is going into that beam that's tight up against that ceiling, right? So we still have that same 180 square feet that's allowed, but now just only 60 square feet is in the ceiling itself. The other 120 square feet is coming out of that beam that's tight to the ceiling. And again, that's that same thing, 2 feet of the ceiling, the rest of that beam, and then you can have that exposed column right there. Now there is a separation of unprotected mass timber. That's what I said before, you can't really do like this whole room of all the walls done because you have a 15-foot separation. So exposed areas have to be 15 feet away from each other. So you can't have that wall and that ceiling within 15 feet of each other. That's in 602.4.2. So here you can see that it's that ceiling area is now 15 feet away from that exposed wall area. And then same thing, even wall area to wall area on that day, there you've got 15 feet separating those two wall areas. Here's just a few other scenarios. So again, here's one where they're taking some in the ceilings. Now we've only got 5.5 feet of exposed ceiling area. And then the rest of that's going into the columns, which are part of the wall exposure. This was in 2000, I believe, 2000 or 2001. Out in Sweden, they did a whole bunch more testing. I mentioned it a couple times at PRG 320, they improved the adhesives, they improved the abilities to withstand fire up quite a bit in these CLT panels. So they did a lot of testing out there. 5 test scenarios. I won't get into these too much, but they did a whole bunch of testing with exposed areas close to each other. Constructed this all out real similar to the test that we did here. Loaded these things up with all the furnishings, all of everything else. We did a whole bunch of tests on this stuff, measured out, again, they were playing around with having some exposed areas closer to each other. And also, I also should have pointed out, all these are exposed ceilings in all these areas. You can kind of see that here at the top, that all those ceilings are exposed throughout. When they went through, they did a whole bunch of testing on that. For the 2024 code, they were able to get G147 passed based off the RISE test, which actually allows for 100% of the ceilings to be exposed now. So in the 2024 code, we're not there yet, obviously. We're not even to the 2021 yet in Wisconsin, but again, you may see this come up in a variance request or an alternative means materials request, right? But now, in the 2024 code, they actually have the testing and the data to prove that you can leave 100% of the ceiling exposed. Now, again, that's if you put all your eggs into the ceiling basket, right? If you wanted to have some on the walls, then you still have that ratio in there of what you're permitted on the ceiling to what you're permitted on the walls.
So you're saying a lot of this has to do with the adhesive changes?
Yep.
Is that standard across the board now, or is that something that
Yes.
you would need to look at to make sure that the adhesive lines up with what they're installing?
No, yeah, everything that they make now has to comply with that PRG 320. So, yep, anything that's coming out is going to meet that. Yep.
So the ceiling area, if the ceiling area is greater than the floor area, then the 100% of the floor area still doesn't mean 100% of the ceiling area.
Right. Yep. Yeah, it's still based off the floor area. So yeah, if you have a angled ceiling or an angled roof in there or something, and your floor area is still down here, yeah, you may need to still cover up some of that roof area, that roof ceiling assembly, something like that. What typically happens though on that is you have a lot of miscellaneous areas, hallways, toilet rooms, utility spaces that you're probably going to cover up the ceilings in those areas, or at least you can. And then that buys you a little bit more than to do something like that. So, yeah.
When going into like existing conditions, you're saying some of these things are changing over time.
Yep.
Is there a way, do these materials have to be clearly labeled in the field? So if like as a general contractor, we're walking into a building and you're having to do some work, maybe attaching an addition onto a building, do we know what we're attaching to?
Well, yeah, actually, there is a requirement in the code with mass timber buildings that the owner has to keep all their specifications and all that stuff with the life of the building. Right. I was thinking of a polite way to say that, but yes, just chuckling at that works. But yeah, so a lot of times I think you're gonna have to rely on the building departments to maintain some good records on that stuff as well. Like I said, the owner is supposed to maintain it, but hopefully the building department will also retain that stuff. But yeah, it's gonna be kind of watching out for some of that stuff. Yeah.
That makes for an interesting discussion. In the state of Louisiana, of all places, not a place that I would suspect would have such a serious rule. Their fire code mandates that the plans, original construction, addition, alterations, whatever plans associated with that building shall be located in a 1-hour enclosure, fully rated, and be fully accessible to the fire department upon their yearly inspection. That's in their state statute, which I find quite interesting.
Yeah.
And it's the responsibility of the building owner. So the moment you buy the building, you're responsible for it.
Yeah. If it's state statute, and everybody's used to it, maybe they do, I don't know.
I'm just saying that
But-
that's, we don't have that in Wisconsin, but it's something that.
Yeah.
I know the fire departments would not argue about.
Right? I think, yeah, it just takes somebody sitting in this room, not working for the state, to push some of these things through. So, yeah, if you guys want to start getting some of that stuff, yeah, it's a process, DSPS actually has a really nice process if you want to submit a code change to them, and anybody can submit a code change, so. Yeah, throw some stuff out there, see what happens. Especially if you do have precedent from another state where you can just cut and paste that language and say, here, other people are doing this, why aren't we? But yeah, keeping an eye on preserving this stuff for the next generation is always I guess a chore, and how do you do that? Especially something that's highly engineered like this stuff's gonna be. Yeah, so some of those 4B buildings, here's a project out in Denver that's using fully exposed already. And this was based off that G147. So people are already starting to use that. I know that there's a project here in the Madison area that is looking at doing fully exposed as well. So there's already people starting to use that test data and starting to use that stuff. So 4C buildings, again, everything's gonna be exposed. I do like this picture just because, again, it does kind of get into a few things just by looking at this of, yeah, you're exposing all that wood, but what do you do with electric? What do you do with, things like that? So yeah, a lot of times with a 4C building, you're looking at all this great wood, but you may have, electrical conduit, you may have mechanicals that are gonna be exposed then. Some people like that look, some people don't, but yeah, that stuff's out there though. 4C building, now you can see all the nice brown on there. It's nice exposed wood, throughout. But again, exterior walls, you still need that 1-layer 5/8 type X. The floors, you don't need that non-combustible topping on there. But then you also do need mass timber covered up in concealed spaces, and then the shafts, inside and outside of shafts. And so that's what a sealed, exterior wall for a 4C building might look like. Again, if it is a 2-hour fire resistant rated bearing wall on the exterior, all that 2 hours is going to be coming out of the CLT panel in itself, right? You don't have any of that non-combustible protection to help with it. I've talked to some builders who have built with this stuff. I said, does it make sense to still throw on, a layer or two of gypsum onto here just so that all that, mass timber, or all that non-combustible protection is there to make that CLT smaller. And what I've been told is that no, making that CLT bigger is a lot cheaper than paying the labor to, come in there, have drywallers in there. You've got all the construction waste now from cutting up the gypsum. All the extra labor of bringing in crews to do that. Just make that panel bigger, and that's a lot cheaper and easier for their construction schedule and everything. And I was just gonna say, I don't know if you guys have any thoughts on
Well,
that.
I was gonna say, can that CLT be used as blocking?
Yeah, I mean, it's exposed, so yep, you can put, whatever you want onto it.
In there aren't going to diminish the rating?
Nope. Nope. So if you want cabinets to get attached to that, anything like that, yep, you're good for all that.
How's it making the energy?
We don't have time to get into that. But Yes, there's two big drawbacks with mass timber buildings and all. Energy code and acoustics. You know, acoustics, you know, you're not gonna hollow corridor, you're not gonna solid corridor. This is all solid corridor, so acoustics just fly through this stuff. So meaning your STC or IIC ratings on residential, it's, you gotta mess around with that quite a bit to meet that stuff. Energy code's similar. However, if you do get these panels big enough, this is just showing a 3-ply CLT panel. I think if you get up to a 5-ply CLT panel, now you're into the mass walls section of the energy code, which you can reduce your R factors quite a bit there, or increase your U factors, however you want to look at it, in that mass wall section. So you don't put as much insulation nowhere near as much insulation as you do in a regular stick frame building. But yeah, you still have to get a bit in there. So especially here in the south.
Typically, they're gonna put the insulation on the
So,
outside
yep.
of that and cover the chip.
Yep.
over the-
Yeah, so they still need that 1-layer 5/8 type X on the mass timber itself. You know, and then you would put some foam insulation or something up against that with another, weather resistant barrier outside of that. Which again leads me to something I've said a few times is you don't usually see CLT exterior walls in this stuff, so. But if you do want to do it, yeah, you're gonna be attaching some insulation out there on the exterior to it. Yeah,
You mentioned that CLT would qualify as a mass wall. Is that a definition that's been updated in the new energy code?
I believe, so, yeah, in the 2021.
Yeah, because, and obviously the next step is people are gonna want to model this in com check.
Yeah.
But they're gonna use CLT for a roof or a wall assembly, and obviously for a roof, you can do all above deck, but for a wall, there isn't anything currently that would work for it unless the definition of mass wall is changed.
Right. Yep, yeah, I know in the 2021, you can, like I said, I think it's once you hit a 5-ply, I'd have to look it up again, but there are some slides at the end of this, but like I said, I don't think we'll get to them today, but yeah. There's something in the 2021, and then who knows where the energy code's going, they're changing to a consensus standard process for the 2024 IECC, so it's just going all over the place now, but yeah. All right, exterior wall sections again. Here's a picture of a 4C building, Heartwood Apartments, that's going up out in Seattle. Fire tests, I'll jump through that stuff. All right, height and areas. I want to make sure we get through this stuff here before lunch, so. Height and areas, there's no real science to this stuff, right? Height above grade plane, actually, this one, there's a little bit, you've got height of ladders and fire department access, some things like that, but I mentioned earlier how that 1A and the 4A are pretty almost equivalent, and 1B, 4B are somewhat equivalent. But 4A or 1A is unlimited everything. They weren't really ready for that quite yet, so. But you do see a lot of similarities between a 1B and a 4B. They're not all exactly the same, but there's some that are matched up. And then the 4C and the 4HT, same thing, they match those up pretty well. Kind of what they did is they just sort of took a ratio then of, the 4C, a lot of times it was doubled-ish, 85 to doubled is 170, but they wanted 180 because of that. And so if you kind of add another one to it, now you got 270. Again, it's a lot of, just kind of, steering the water, seeing what people are comfortable with for this first go around on it. So, you can see a lot of similarities on that, but then you do get some things here where they do, reduce down and just maintain that 65 feet. For a I1 condition 2. There's different things like that. So allowable stories, very similar type thing here as well. They knew they couldn't do unlimited. When the ad hoc committee was going through, they actually had an engineering firm who ran through their software. They had just designed a 40-story building with steel and concrete, ran through their BIM software, replaced all the steel and concrete with mass timber. And the software said, yeah, you know, your 40-story building is gonna be fine with mass timber. So there are people, you know, looking at 40 stories, there were people saying, well, we can't go all the way up to 40 right away, let's go around 2024. And so they ended up settling on 18. I've talked to the people that were in the room, they said, you know, somebody threw out 18 and everybody said, yeah, we're comfortable with that. And that's kind of how it all happened, so. And then again, you know, sort of the ratios down from that, so. Again, you see some similarities with the 4B or the 1B and the 4B, but not real precise, but kind of that cap at 12 is also where you get 4B capping at 12. Let's see, that's just more number of stories. Again, I won't get into these too much because, you know, you guys can read the code and see what's all in there. Allowable areas, this is one where it was just a straight math equation. They took 4HT, multiplied it by 1.25 to get 4C, multiplied the 4HT by 2 to get to the 4B, multiplied 4HT by 3 to get to the 4A. So just a straight equation. Said everybody good with this, and same thing. Everybody said, yep, we're fine with this. So that's how those tables were all developed.
So with the fire test you were showing earlier, they had some that were covered, so it's your A and B, and you had some that were exposed, which was this, probably the C, right? But those were sprinklered?
Right.
So what about a C that's not sprinklered? How are they developing non-sprinkler type 4C for basement areas?
Yeah, basically still same thing, you know, you got the non-sprinklered line in here. You know, so like an unsprinklered, again, they were just taking that 4HT and just multiplying it out by, you know, the factor for each of those different categories.
I guess what I'm wondering though is, was there testing that was done for that, or is that, did I miss something in those tests, or was that later testing grounds where they kind of covered non-sprinkler?
Well, so some of, you know, keep in mind, yeah, 3 of those tests, they did ran no sprinklers going off at all. But yeah, in terms of developing height and area tables, they really didn't test those, other than I think they ran them through some BIM software and stuff, just to make sure, you know, structurally that it would be fine. But you know, once you have those elements and you have them protected to a certain level, you know, how big you go is really kind of not an arbitrary number, but it's based more off of you know, other elements in the code already, I guess.
They're probably basing it more off of the existing heavy timber area than anything else.
Yep, and it kind of goes along with protection, right? You've got your 4HT, which is your old traditional buildings. Now you're protecting a little bit of those elements now with in the 4C, where you're you know, you're protecting your stair shafts, you're protecting the exterior side of exterior walls. You've got, you know, your bigger mass timber buildings, so there's a little bit more protection, so you can go a little bit more bigger and taller. Now with the 4B, now you're adding typically 2 layers of 5/8 throughout, or one layer of 5/8 throughout for sure, sometimes 2. And so now, you know, you've got another step of fire protection to it. And then in the 4A, now you've got potentially 3 layers or at least 2 layers on everything. So that's sort of another step out. So that's kind of how they came up with them. That's not real scientific to it, but yeah.
The thing that stands out to me is how much more area you get than you do on a type 2 construction. Is there rationale, like they're safer?
Yep, yeah, because again, yeah, remember, we're matching those fire resistance ratings of the 1A and the 1B. So that's where, but again, 1A, 1B, they're all unlimited areas, so they weren't comfortable doing unlimited area for everything. So they had to come up with some ratio, but yeah, exactly. You know, you look at what, you know, a type 2A, A1 sprinklered 1-story, you know, you're at 62,000 here. If you did a 4A, you're at 180,000 square feet, so.
So it's fire resistance ratings being higher on.
Yeah, but keep in mind, you know, with a 1A, or I'm sorry, 2A building, you just have one hour on everything. Whereas your 4A, you've got 3 hours on on everything, your structural frame, your primary structural frame and exterior bearing walls. So you've got that at 3 hours, rating for a lot of stuff in here. Whereas here you've got, 1 hour or nothing in a 2B.
One other thing, isn't there, going back to table 601, is there any equivalent to the reduction in rating that the 1 and 2 get for being a high rise, or does that not exist?
Yeah. So, all right, any other questions on it? Yeah.
It's, so how does that, what's it impacted by a holding construction? So, yeah, from 1, 2, 3 minutes, is that above that level then?
So yeah, your number of stories, yes, yeah, you can still do that, but your height is still based off of your grade point. So when you go back to,
Based on the grade point, not the, not the level of holding.
right, yep. Yeah, so that's still based off grade plane. Your stories though, yeah, once you get that podium, you kind of get to start over as long as you're separating that out into 2 separate buildings then. And then, yeah, so you could still, the Ascent Tower, I think was 18 stories on top of a 7-story podium. They had a ton of variances for a whole bunch of stuff in there, so you can't really go by what the Ascent Tower did, because they didn't really follow the code all that much, but not they didn't follow the code, but they gave them a lot of exceptions to the code, so, yeah.
Say about that.
All right, so here's sort of a last little recap on some of this stuff. So 4A building, maximum height 270 feet, you can go up to 18 stories. Again, fully protected mass timber, sprinklers throughout, 3-hour primary structural frame. Stair towers, non-combustible once you get up over 12 stories. Concealed spaces, you gotta just protect those, and then that non-combustible, 1-inch non-combustible floor topping. 4B, 180 feet high, 12 stories max. Most of your mass timber is going to be covered up. Sprinklers throughout, 2-hour primary structural frame. Stair towers are protected mass timber or non-combustible, and then still that 1 inch of non-combustible topping. Type 4C, maximum height 85 feet. Number of stories 9. Fully exposed mass timber though, and no floor topping on that. That's just sort of a real quick visual of comparison between the 4. All right, questions on any of that stuff? Yeah.
So those 3 conditions on the right in the previous slide, you could have the stair tower essentially made of CLT panels all the way up to 12 stories.
Yep.
And.
Yep. And then just protecting it. Yep.
It's like most of these use those for the shear though, so.
Yeah.
The wood
Yeah.
would have a decent amount of shear, but especially if it's 12 inches thick or 8 inches thick, then,
Right.
yeah, I don't know. Just the fact that you can make it out of wood is a.
Yep. And there is, yeah, and you bring up shear, it's not part of this presentation, but AWC out on our website, we do have a whole bunch of recorded presentations and stuff. We actually just did one on CLT panels being designed for shear. I want to say maybe late last year or so. Within the last year, we did a presentation on that. So if you're interested in learning more on that, you can go check that one out. I think it's like an 1.5-hour presentation, something like that.
Is there very little shrinkage then, or?
Yeah.
Because that would seem like be major.
Yep, yeah, these things are highly dried down and dried out, and again, through the engineering process too, it takes out a lot of any other excess moisture that's in there, so. I want to say Ascent Tower, I think that's only gonna drop like 1 inch or something at 18 stories. I think they have like 1 inch or shrinkage, something like that, I want to say. It was very, very little.
So on the job site, are they really highly protected, the panels into, so that they're not getting moisture coming in at that stage, or when they're on the ship?
Yeah.
From Europe?
Well, I think even if they do get moisture during construction, that's gonna dry them back out, and, once that building dries out, that they're gonna shrink back down to what they are, but.
But that's not the problem.
Yeah,
You know,
it's eventually.
Footprint construction,
Sure.
this more floors on stacking on top.
Right.
You know, especially compared to the outside walls where they're probably on concrete for
Yeah.
foundation.
And that's more with your traditional wood though, you know, your traditional stick frame wood, yeah, that's gonna shrink a lot more, than this stuff will, like a lot more. I don't have an actual numbers, a lot. We'll go with that. That's a technical.
Yeah, I think Tom's more concerned about swelling on, say, leaving it out over the weekend in the rain.
Right.
So, I mean, the construction of the building you showed earlier that was, you know, a time lapse.
Right.
There was no covering of the CLT as floors went up one after the other.
Correct, yep. Yeah, so it could swell during construction, but I think once you get that building sealed up and you start getting the HVAC run through that, it's gonna shrink right back down to where it was.
So how do you get your holes, like your dowels, like if you're gonna do, you know, fitted assemblies? How do you get them to work if they're wet?
Things are starting to,
Yeah,
and that's why, yeah, when the stuff comes out. I don't know. I don't know if during construction, if they have to hold off in the rain. I guess I haven't really asked that before.
What if it swells over the weekend and you get a new truck coming in the flat that brings the panel on
and
one
it's
day?
dry.
Yeah.
You got it connected somehow.
Yep. I don't know. New product.
Are you allowed to re-drill the holes?
No, and I know that, yeah, that they don't want you doing any field modifications to the stuff at all. Okay. So, yeah, I think you either just cut it around till it dries out or.
No, that's like my experience with CLTs that I had on a couple of buildings, that there was a preservative that's part of the process that goes on when they're done. We had panels that were made in Finland and shipped over in containers for the project that I was working on. You know, they came in lengths from 16 feet to 28 feet in containers on the ship. And were brought out to the job site in the containers. So they stayed in the containers till the guys took them out of the containers.
Right.
And put them up. So that's one of the things you gotta think about. They're not just coming on a big truck and sitting outside for the most part. Because, as you said earlier, there's not many places locally that make these panels.
Right.
The big manufacturers are all across Europe. Right now. I think there's one or two in Canada.
Yeah, and here, so Sterling, engineering, they just opened up a plant south side of Chicago. Just within the last 6 months, 9 months or so. So that's why, yeah.
Several years ago, so there was
Yep.
nothing that was around here.
And I don't know if anybody knew Archie Landerman from Woodworks. He actually left Woodworks and went to go work for Sterling. So, yeah, if you guys know Archie, I'm guessing by the laugh. Yep. Yeah, he's down there with Sterling now.
I just was thinking, we were talking about this, about the longevity of the buildings and, they're new here, but they've been used here for a while. And as these buildings get older, they go through owners, and they go through changes that you're gonna see for the local inspectors, knowing that modifications are gonna be at that point. You're not all getting now,
Right.
but I'm thinking about future remodels, and things like that. Local officials are gonna have to know what they're dealing with.
Yeah.
Kind of changes might happen.
Yep, definitely. Or you get, I mean, I'm sure everybody in this room has been, to apartment buildings, and you get some really nice fire stopping up in the attic, and then, Spectrum or, a new company comes in there and starts smashing holes in there to run cables through. So, yeah, exactly. Now they're gonna start, drilling holes down to core down to the next level. More stuff's going wireless, so that's good, but yeah, there'll always be wires and cables and pipes. Yeah, pipes, I mean, yeah. So, yeah, exactly. It's something that that's a very good point that, through the life cycle of these buildings that, I think you're gonna have to watch this stuff. And yeah, I don't know where that's gonna go, I guess, in the future right now.
To that point, do you know, is the 2024 IEBC starting to talk about this?
Nope.
You got differences between the 21 and the 24 in terms of what you're allowing.
Right.
And
No,
so,
it hasn't touched it yet, so.
Yeah, you imagine a condo owner who does a remodel in their condo, 2-story condo within a building, and they want to put a bathroom over here. Well,
Right.
now they're building 4.5 inch wall.
Yeah. Exactly.
well, or even just, I'm going back to the, amount of exposure with different adhesives and then I knew that if we don't really have a label
Well,
anywhere,
stripping off or something.
you know, hey, I can do 100% snap in today's code. Why am I limited to 20%? You know, that's.
Or even just that condo owner that doesn't know and says, hey, you know, I've got a chunk of my wall here that's exposed. And if somebody told me that wall goes all the way through, I'd like the look of that. I'm gonna rip off all this gypsum and so, yeah. Could happen.
The toilet that's set and it's leaking from day one, but now there's enough stuff that it can just suck it up for
Right.
a long period of time
And eventually
until there's.
until it can't.
It can't.
Yep. So, yes, and again, and that goes back to, you know, what I said earlier, you know. Less than 40 years, the stuff has been being used, so. New stuff, new testing, new experiences are being done every day with this stuff, so. Where it's gonna be in another 15, 20 years from now, who knows, and another 100 years from now, who knows? So, yeah, it's a very new product in terms of, you know, we've been using, you know, concrete, masonry, steel, stone, you know, we've been using that stuff for thousands of years. This stuff is, you know, younger than anyone in this room, I think, right now, so. All right. I want to touch on just a few more things and then we'll break for lunch here. Separated mixed use buildings. If you are using CLT walls, you do need at least 1/2 inch gypsum on each side of a CLT wall that's separating out mixed use buildings or mixed uses. Same thing with incidental use areas. If you have an incidental use area and you have a CLT wall that's dividing that, you need at least that one layer of 1/2 inch gypsum on both sides of that. Shaft walls, we talked about that quite a bit. I'm gonna skip through this stuff, but again, you know, you need that same protection on the inside and the outside. So 4A, 4B, you've got 2 layers, 5/8. Again, that's gonna take up 80 minutes of it, but that other 40 minutes still has to come out of the CLT itself. There's some sealant requirements, whenever you have mass timber that are butting up against each other. That's in the code. You can use mass timber elements for fire blocking in the code, that got added in. Penetrations, once they've been, tested for that, I've been told that there's no real, change to requirements for penetrations. It's the same penetrations that you would get on a steel and concrete type building, so. But again, just kind of make sure that they're listed for that. Once you get up over 120 feet in the building height, 4A, 4B, you are required to have a redundant water supply, so 2 water mains coming in for that sprinkler system, off of 2 different streets. That requirement's already in the code for 420 feet for a high-rise building, but 4A and 4B, once you get up over 120 feet, that requirement comes in as well. All right, concealed spaces. I'll just run through this real quick. So again, concealed spaces, type 4A, 4B, you need 2 layers of 5/8 inside, covering up any mass timber elements in a concealed space. Type 4C, you need 1 layer of 5/8 type X covering up any mass timber in a concealed space. Here's one of those new ones. Like I said, 4HT is pretty much unchanged other than concealed spaces. You are permitted to have concealed spaces in the old traditional type 4, the new 4HT now. And you've got 3 options for that. So you can, if that building's sprinklered throughout with sprinklers in that concealed space, you can do that. That's option 1. Option 2, filling that concealed space completely with non-combustible insulation. Or option 3, covering up all the mass timber or all combustible surfaces in there with 5/8 type X. So the old traditional type 4 construction, you can do concealed spaces in there. And again, 4A, 4B, 2 layers, 4C, 1 layer, 4HT, 3 options that you can do. And again, those were all tested. Let me jump through a few things here. You just want to touch on this real quick. So I think it does maybe come up a little bit later on, but for any structural engineers, or anybody who's reviewing structural engineering drawings, you structural engineers, when they're designing this up, they are gonna have to look at this both ways, right? They're gonna have to look at the building as they're building it, and then they're gonna have to look at the building after a fire. Because, you think about that char layer, so if you have a CLT wall here, you have that on the left, just as it's installed. On the right here is after a fire, right? And you're gonna have that char layer, that really has no structural capacity, where that chunk of wood is no longer there. So all of your connections, all of any loads that are on that wall, especially on a bearing wall, you're taking all those loads on that centroid of that wall, right? All your moment connections, all your moments, all that stuff is all coming down the centroid of that wall. Well, when it's installed, it's here right in the middle. After that fire, that centroid of that wall shifts over a little bit. You kind of see that there, it'll move over, an inch or so. So you need to be watching for that stuff. There's a few other things later on, just with the size of beams as well, that they need to kind of watch out for as well. So just kind of keep that in mind on bearing walls, that centroid is going to move based off of, where it is installed today and where it's going to be after a fire event. All right, let's see. There's that thing on owner's responsibility. It's actually in the IFC, so it's not even in the IBC about maintaining those records. All right, and with that, why don't we break for lunch for an hour, and then we'll come back, and there's just a little bit on fire protection that I'll cover after lunch, and then we'll get into the shear walls and then do some Q&A at the end. So we will get back here at 1 o'clock then.
Folks, we'll be back at 1 o'clock. Thank you. If anybody's looking for something to eat, there is within walking distance, the Chipotle, McDonald's, and a cooking place right across the street. Go. Otherwise, there's a great name. There's a dumping house there down the block. But then there's also vending machines and like cafeteria down on the way.